Hello, good evening, all.
Hello.
Good evening, ma'am.
Hello,
Yes, so today is our last session for this quiz 2. And today we are going to see the mock solution. So you have two mock on a portal. And first we are going to look at the solutions for mock 2. And after that, we will look at some few problems from mock 1. The mock 1 is quite easy, not so difficult. So I've taken just few problems from there and we'll discuss that after we finish mock 2. Okay. So let's start the session now.
first question now.
Ma'am, would you be uploading this video, ma'am?
This video, yes, we will be uploading this video.
Ma'am, please try to
Hello, ma'am.
do it by today itself.
By today, yeah, I will try. Today, I think it will be a little difficult. It's already night.
Ma'am,
But let me see.
had there been a session before this for quiz 2? Is this the second session?
For quiz 2, this is a mock session. Yesterday, there was one session which RTA had taken, and that session was for week 6 basically, and before that there were two revision session happened, one for week 5 6, one for week 7 8.
Okay.
So you can check those on YouTube, it is available. For
So since I have not attended those sessions, do you suggest me to first go through those sessions in order to understand what's happening?
okay, so week 5 6 revision session, week 7 8 revision session. uh if you're planning to revise, if you haven't revised it, it would be good if you just go through the session. You can get to know all the things that is there on in those weeks. But if you're quite comfortable with, I would say you can skip. There's no problem.
Okay.
Ma'am, the solution code for quiz 1 and quiz 2 PDF will be available in the portal by today.
Mock
Mock
solution,
one
you
and
mean?
mock
Mock
one.
Yes.
one, by
Sorry,
tomorrow
mock.
morning it will be uploaded.
You will just provide graded assignment solution like this. If you provide the PDF of quiz mock 1 and 2, then it will be helpful for us.
Mock solution for quiz 2, mock test 2 is available in WhatsApp groups, in statistics 2 WhatsApp group.
Yeah,
You can
you can check
No,
over there.
I have no statistics to WhatsApp group. I don't know what is the
Manan,
link.
can you send Shampa the link?
yeah, so I'll try.
You can take help from others and check if somebody has done.
If you provide
Ma'am, I
the
am
link in the
also not aware
So,
whether there is any
group
WhatsApp group for stats 2.
Even we are not. Even I was not aware of it. Just now I got to know.
I
So
also don't
you should
know.
try to
Maybe
take help from your
it's not
peers.
official group, is it?
It's not an official group. It's not an
No,
official.
there are no official WhatsApp group. These are all
Yeah.
student initiatives.
Okay.
So you can be a part of some group, students group. You will get a lot of help, problem solving and all that.
Ma'am, previous revision sessions aren't available on YouTube channel.
Previous revisions, it should be there
I
on the
couldn't find them.
YouTube.
I think they haven't uploaded on the YouTube.
No, it was on the another statistics 2 channel.
These available.
Are you able to see the screen?
No, ma'am.
Yes, ma'am.
Yes, ma'am.
No.
Yes, ma'am.
Okay.
No, ma'am, screen is not visible.
Not visible.
Visible. Wait. Is it visible now?
Yes, yes.
Yes, ma'am, it's visible now.
Yes.
Okay.
Good evening, ma'am.
Yeah.
Ma'am, today one session was scheduled at 4:30 to 6, but it was rescheduled to yesterday, ma'am.
No, it was actually scheduled for yesterday. I think some misunderstanding happened there, so we had later changed it to Thursday.
Yes, ma'am, because we were
Yesterday.
waiting for that, and I have seen day before yesterday night, it was scheduled on Friday only. But when we
Okay,
see
so day
yesterday
before
evening-
yesterday, you're saying it was scheduled today.
yes, ma'am. Only yesterday only it
Okay,
rescheduled to yesterday itself.
Okay. So that session was basically for week
For week
6.
6. Yes, ma'am. We were requested actually.
Yes.
So it was
you can watch it on YouTube if you
But
have
YouTube
missed it.
link is not available, ma'am, for that. I
Not
checked for that.
available.
Yes, ma'am.
Actually,
So if
actually,
you
Ma'am,
are
have
able
you
to
joined
provide
from
it,
3 devices?
please, ma'am.
I
Sorry.
sent that link in the chat box.
Ma'am,
Can
have
you
you
share
joined
that
from
link,
3
ma'am? Because
devices?
it is
Yeah.
not available in our calendar.
No, I have not joined from 3 devices.
Actually, I can see 3 of your tiles. I'm
Wait.
A1004 presenting.
Let me join. Let me join again.
Yes, even else.
Wait, I will rejoin.
I sent under my name there is a link of yesterday's class actually. Is there? Can you hear me?
Thank you so much. Yeah. Thank you. Anime.
Check. My name is Deepti and
Oh,
under
Deepti. Okay.
Hello, ma'am.
Okay, ma'am, you have joined and the screen is visible.
Yeah.
Ma'am, you are not audible.
Okay, sorry, I was on mute. All right, let's start again. So you have 10 samples coming from the exponential distribution with parameter 5. Okay. So here the parameter here lambda is 5. Now you have to compute the expected value and variance of the sample mean. So what do you know about the expected value of sample mean? Like, what is this?
It is equal to population mean, ma'am.
It is equal to population mean. And in this case, what is our population mean? It is just, it is just 1 by 5. So why is it 1 by 5? Because our x is, so x here is exponential 5, right? And in case of exponential distribution, expected value is 1 by 5, 1 by lambda, right? So if you have a parameter lambda, then expected value is 1 by lambda and variance is 1 by lambda square, right? So that's why expected value of x bar will be 1 by 5. Now, what about variance of x bar?
Variance of x divided by n.
1 by 25 divided by 9.
Variance of x divided by n.
9.
N.
Why 9?
By 10.
1 by lambda.
So variance of x divided by 10. So what is variance of x? Variance of x will be 1 by 25, right? So 1 by 25 divided by 10. So you have 1 by
Hello, ma'am.
250.
One thing saw comma separated questions, some question given comma separate. So do you expect that type of question in quiz 2?
Comma separated with.
I need to put the comma separated answers.
Okay, no. You will not expect those type of questions in the quiz, like write the steps. No,
Yes.
that is not there.
Okay. That's helpful.
Okay. So what is the correct answer here? Expected value of x bar is 0.2 and variance of x bar is 0.04. So option B is correct. So it was a very simple basic question. I hope you don't have any problem solving this.
No, ma'am.
Okay.
No, ma'am, it was okay.
No, ma'am.
Okay.
Oh, man.
Let's move forward.
Ma'am,
Yeah.
I have a doubt. Ma'am, there's a difference between sample mean and sample variance and population variance of population. So here we are asked to calculate the variance of sample, which
We
should
are asked to calculate the variance of sample mean,
Yes, ma'am.
right?
Sigma square by n.
So what we were asked is, so it is given to us.
Ma'am, actually sometimes we are using the formula in which we divide the variance by n minus 1
I will
instead
tell
of
you.
n. Yeah,
See, you have samples, NIID samples, okay? So you have x1, x2 up to xn. They are, let's say, IIDX. All right. So IIDX saying they are all independent and the distribution follows the same as what the distribution is for x. Now we have defined our sample mean x bar as x1 plus x2 plus up to xn divided by n. Right. Now, what is asked in the problem? In the problem, it is asked you to find what is expected value of x bar and what is variance of x bar, right? So if you have seen in the lecture, you will know that expected value of x bar comes out to be same as the distribution mean, right? So it will be same as expected value of x. So how it comes out? Do you know the derivation part of this?
Yes, ma'am. I know the derivation.
You know this is this, right? And then you have variance of x bar that comes out to be sigma square by n, and this sigma square is this variance of x. Okay, so variance of x by n. So even this derivation part you must have seen in the week 7. Now
Yes,
what
ma'am.
you are talking about is sample variance. So this x bar is sample mean. Now we
Okay.
have something called sample variance, right? So sample variance, we have defined S square to be sum over xi minus x bar whole square divided by n minus 1, right?
Yes, ma'am.
So this is sample variance. What you're talking about is sample variance. But here we are interested in finding the expected value of sample mean and the variance of sample mean.
Ma'am, there's a small doubt.
Yes.
In variance, shouldn't it be when it is variance of x bar, it will be variance of x1 plus x2 all the way up to x10?
Yes, ma'am.
Divided by n.
Should it not be?
And then
Right.
1 by n will come out, it will become 1 by 100. And 10 times the variance of x bar will be 10 times 1 by 25.
Okay, I will tell you what is happening there. So you have variance of x bar, okay? And x bar is x1 plus x2 plus up to x10 divided by 10, right? Divided by 10. Now, using the property of variance, I will write this is 1 by 100 variance of x1 plus up to variance of x10. Now, all these x1, x2, x10 are independent. So, I can write this as 1 by 100 variance of x1 plus up to variance of x10 separately, right? But they are also IIDs. They are also identically distributed to x. So I can just write 10 times variance of x divided by 100, right? And what it becomes? It becomes variance of x by 10. So when you see here sigma square by n, right? So we say variance of x bar comes out to be sigma square by n. So like you have already cancelled out this n square and n term from n from numerator denominator. So you are left with this sigma square by n. So I hope now it is clear why variance of x bar here is variance of x by 10.
Yes, ma'am. Yes.
Yes. Okay.
Ma'am, I have a doubt.
Okay.
Ma'am, what is the expected value of sample variance?
Expected value of sample variance. It comes out to be the sigma square. Yeah.
Sigma square by n, ma'am.
No.
Not n. It just comes out to be sigma square. So this derivation you would have seen in some of your I think assignment or lecture you would have seen.
Yes,
this.
tutorial is present, right?
Yes.
Tutorial.
So you can check that out. So expected value of s square comes out to be sigma square.
Excuse me, ma'am.
Even lecture also discussed.
Ma'am, by when will the answer?
Can you derive this, ma'am? Expected value of s is sigma.
I would suggest, can you just once look at the tutorial? It is already available.
Yes.
Ma'am, I was asking by when will the answer keys be uploaded on the portal for mock 1 and 2?
It is already there, I guess.
Oh, it's there?
Yeah.
Ma'am, under which section? Is it under...
No, not the solution. I mean, the answers, what the correct answer
5 and 6 are not available.
5 and 6 are, yes. So just now somebody had mentioned a WhatsApp group. They have the solution with them. Can you take help from them?
Okay.
Yeah. Okay. Let's move to the next problem here.
So, ma'am, the solution will be uploaded, right?
It will be uploaded, yes. So the same document, I will upload it by tomorrow morning.
Okay, okay.
Ma'am, this is mock 2 or mock 1?
This is mock 2.
Ma'am, mock 1 is already discussed or what?
No, we'll discuss it after this. I had said in the beginning, we'll discuss it. Let's not get distracted there. Just focus on how to solve the problem first, okay? So I hope question number 1 is clear to all of you. Now, moving to question number 2. It says x and y be two independent exponentially distributed random variables, each with expected value 1, right? So what is given to us here? You have two random variables x and y, and they are independent, okay? They are independent and they're also exponentially distributed. So x follows exponential random variable with, so since their expected value is 1, so it means their parameter is 1, right? And even y is exponentially distributed with the parameter 1. Now, since x is exponentially 1, your fx of x is what? E to the power minus x, right? Because if you know that if x follows exponential lambda, then fx of x is lambda e to the power minus lambda x for x greater than 0 and 0 otherwise, correct? We know that.
Yes, sir.
So in this case, since our parameter lambda is 1, fx of x will become e to the power minus x, right? This is for x greater than 0. And fy of y, right, that will also be e to the power minus y for y greater than 0. Now look at the first question over here. So the first question asks you to find the probability that x is less than 2y, right? So how do we approach such kind of problems? What should we do first?
Joint density.
We have
first calculate the joint
That
density.
means y is greater than x by 2.
Yes. So first we should look at the
It is
reason.
given that
We should
expected
change
value
less than with equal to symbol and draw that line so that we can identify the corresponding area.
Yes. So first let's try to look at the
No,
reason.
first we have to find the joint density, na?
First look at
Joint
the reason
density
here.
function.
Yes, we have to look at the joint density function.
And only we can integrate afterwards.
So what is this x less than 2y? So if this is our x and this is our y, we have this is our x equal to y, right? Now, if what will be the reason x less than 2y if in this graph?
Above region.
Above reason, right? So this whole thing represents, this represents x less than 2y. Okay.
Yes.
Now we have to find this probability that x is less than 2y. So what we do, we'll have to integrate our fxy with respect to dx and dy, right? Now what is the joint density here?
And joint density is e power minus x into e power minus y.
Right.
That means e power minus of
Yes.
x plus y.
Because they're independent, they can be written as product of their marginals.
Yes. Since x and y are independent, I can write this as e to the power minus x into e to the power minus y, which becomes basically e to the power minus x plus y, right? And this is dx dy. So now we have to integrate, right? And
Now the task is to find the limits.
Yeah, how do you find the limit now?
When we fixed one, maybe we can fix the x
So
one.
let's say, yeah.
Let us
we
fix
have to
the x.
fix the
Let us
decrement.
fix x.
And then we can vary y.
And fix that.
We can vary y, right? Okay. So let's write, I will write e to the power minus y outside. Okay. Sorry. Let's write e to minus x outside. And e to the power minus y dy. Let's first integrate with respect to y, fixing our x. Okay. So what is the limit for y integration?
Ma'am, it is for
Y to 2y. Y to 2y.
x by 2 to x to infinity. X by
Okay,
x by 2 to
one
infinity.
by one. X by 2
Ma'am,
to
when we
infinity.
fix the x,
Yes.
when we
So
fix
x
the
by
x,
2
then y
to
varies from this
infinity.
line to the infinity, right?
Yes. So we are fixing our x, right? So we are fixing x. We are fixing some x. So once we are fixing some x, then our y is varying from this point over till infinity. And what is this point here? This point is on this line x equal to y, and this is y equal x by 2. So your y is varying from x by 2 to infinity, right? And what will be the range limit for x?
0 to infinity.
0 to infinity.
0 to infinity, right? Now let's integrate this. So you have 0 to infinity e to the power minus x and e to the power minus y integral. So you have e to the power minus y by minus 1 you have, right? So let's write it outside. And you have x by 2 to infinity dx. So once you solve it, what will you get? you will get minus e to the power minus x 0 to infinity, e to the power 1 by infinity 0 minus so you have minus e to the power minus x by 2, right, dx.
Yes, ma'am.
So basically you got integral e to the power minus 3x by 2 dx, x varying from 0 to infinity. Correct?
Ma'am, it is plus e to the power
Yes,
minus
ma'am.
x with
Right.
Sorry?
Yes, ma'am. Yes, ma'am.
Can you repeat?
How did this minus sign came in here?
It is plus, ma'am.
From integral itself, no, minus 1 by 2 we divide it with.
No.
Minus 1 we divide with coefficient of y.
No, no, ma'am, it's okay.
Which
The lower
we are discussing?
Ma'am, x by 2 to infinity, how it came?
Okay, can you tell me if all of you got this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Ma'am, please share that.
Clear till now.
Yes, ma'am, got. Ma'am, I have not
One
got.
by one. Can you tell me what is the problem here?
No, ma'am, it's you take the minus out, so I'm confused.
Oh, take
How
the
did this minus came out, madam?
minus came out because integral of the integral of e to the power minus e to the power ax dx. What is this? This is e to the power ax by a, right? So since I have to integrate e to the power minus 5, I will do e to the power minus 5 by minus 1. So that minus 1 I have written it outside, right? And now basically, so this will be e to the power y, and the limit is like x by 2 to infinity. Okay, I'm just dealing with this inside bracket part right now. So this becomes 1 by e to the power infinity. So 1 by infinity basically. So 1 by infinity is what? 0, right? Minus e to the power, 1 by e to the power x by 2. Correct? And this becomes minus of e to the power minus x by 2. So this is what I have written over here.
Yes, now understood.
Understood now? Okay.
Then the limit part, can you explain again?
Got it.
So limit part, see, what we are doing is we are fixing our x and varying y. So if
So
we are,
when we are just differentiating with y, so at that time what we are fixing?
see, we have two variable here. One is x and one is y. Now, when we have to integrate, what we do is we fix one of our variable and vary the other one. So what we are doing is, like if you look at this step here, so we are fixing our x. Okay, so we are fixing our x. So e to the minus x, we have taken it out, and we will vary y. So look at the figure here. So you're fixing your x and you're varying your y. So you see this shaded region here, right? And you see that once you fix your x, your y is varying from this line x equal to y to infinity.
Okay.
Right? And what is this line? This line is x equal to y. So you would want to write, you will write your y in terms of x. So since your y is varying from x equal to y, so x equal to y, you will write y in terms of x. So y equal x by 2. So y is varying from this x by 2 till infinity.
Okay. Okay,
And
got
your
it.
x is varying from 0 to infinity.
Ma'am, we can do it in the other way too.
You can do it in the other way too, yes.
And there we will take the limit from 2y to infinity.
Okay, so let's draw another figure here. You have this is x equal to y, okay? And this is your shaded region. Now what we are saying is we will integrate first with respect to x. So we are fixing our y. So we are fixing our y, okay? So if we are fixing our y, how is the x varying?
From 2y to
0 to 2y.
0 to 2y.
0 to
X is
2y.
varying from 0 to 2y. And y is varying from 0 to infinity.
Ma'am, actually, I am having a doubt. So basically, if when we are drawing this region, can't we take consideration to the e to the power minus x plus y into this graph also, and the point at which both intersect and the specific region in which,
which graph you're talking about?
for example, in this one, that this x is less than 2y.
Okay.
So in this graph, can't we take this function also e to the power minus x plus y into this graph and the intersecting point?
Yeah, but wouldn't that become very complicated?
Okay, so basically
Drawing,
region will be
because it will be a region, and it will look we don't actually know. It's very difficult to draw from hand how this region looks like.
The point on this graphs represents the joint density, right? So that is not the e raised to minus x graph.
No, like if you want to take the region here and try to look at what the limit and all, the surface
This graph which you have drawn is a graph of joint densities, right?
Yeah.
Every point is representing joint densities.
Exactly. As long we take this graph into this, so the limit changes. We have to take the point at which the intersect on the x less than 2y line.
Yes, and that picture will be very complicated here to draw.
I in that way and just unable to understand when I was doing this question.
Okay. So just looking at the support, we try to see how this x and y are varying and then integrate. Like,
can you please explain?
Calculation part, it's much like simpler.
This one is understood. I was just thinking. Thank you.
Can you please explain why we take the y limit to be x by 2 to infinity and the x limit to be 0 to y?
X limit to be 0 to 2y. Okay. So I have drawn two figures here, right? So let's erase this. So the first figure, you see that I have fixed my x and I am varying my y. Okay. So once you are fixing your x, your y is varying from this line x equal to y to infinity. Correct?
This is my question. Then why not from 0 to x?
Why not from 0 to x? Because it is x less than 2y. I mean, what the reason you are interested in is x less than 2y. This is a question. X less than 2y, not x greater than 2y. So x less than 2y is the shaded region. So that is why if I'm fixing my x, my y is varying from x by 2 to infinity.
You can take it as 2y greater than x. Y greater than y greater than x by 2. You can take it that way also. That would be more clear.
Okay.
Yeah.
Okay.
Ma'am, one way you had explained it earlier, which is also what I thought was quite good.
Okay.
See, the point on x which you have fixed, that point on the x-axis is actually x0. And that 0, when it moves up, it hits the slanted line at x by 2. So y basically has to go from x by 2 till infinity.
X by 2 till infinity. Yes.
Yes, ma'am. Actually, this is x is equal to 2y, so we can consider y is equal to x by 2 because we are taking limits for y.
Yeah,
So
I mean it's the same thing. I mean,
guys, can we move forward? There are a lot of questions.
This question is taking much more time than expected.
No, there's a second part of the question where we are given that x is less than 2y, but it's greater than y.
Yes, there's one more part coming.
Yeah, so that's actually
so after this you just have to do the integration, right? Now let's look over here. So you have integral 0 to infinity e to the power minus 3x by 2 dx. Okay, so you have to integrate now with respect to x, and it becomes e to the power minus 3x by 2 divided by minus 3 by 2, right? And it is 0 to infinity. So this will become, when you solve everything, it will come out to be 2 by 3. So 2 by 3 is the answer for this particular question. Now there is one more part for this question, and it says find the probability that x greater than y given x is less than 2y. Okay, so let's draw the figure again. You have two curve here. One is x equal y, and the other is x equal 2y. So this is your x equal y, and this is your x equal 2y. So probability x greater than y given x less than 2y, right? So
it would be the region bounded by these two lines, right?
Yes, yes. So this is one event, this is another event. So probability A given B is what? Probability that x is greater than y, comma, x is less than 2y, right? Divided by probability x less than 2y. Okay. So you see here, so it's saying probability x is greater than y. So x greater than y means this reason. Okay. And x less than 2y is, let's draw this.
Our reason of x is equal to 2.
Right? And its intersection is this reason, right? The intersection is this one. Correct? So if you look at the numerator part, you have to find probability x greater than y and x less than 2y. So you have to find this probability in the intersection. So what will it come out to be? Again, you will have to do the double integral, and it will be double integral e to the power minus x e to the power minus y dx dy. So let's fix x first. So if I'm fixing my x, how is my y varying?
From x by 2 to x.
From x by 2 to
x.
And y is varying, and x is varying from 0 to infinity.
Should it not be dy dx?
I mean, this is not a problem. So what you can do is you can just pull e to the minus x out, and you can write e to the power minus y dy dx. That is not a problem. You write dx dy dy dx. It's not an issue. So again, you have to do the integration and substitute the limits. So
now y goes from x by 2 to x.
Can you do that part?
Yes, ma'am. Yes.
Yes, ma'am. Go ahead.
Yeah. So I will just I will just write the final answer here. So once you integrate it, you will get 1 by 6. Okay. You will get 1 by 6. Now, what is the question? Yes, the question is probability x greater than y given x is less than 2y. So the question is probability x greater than y given x less than 2y. So in the numerator, for the numerator part, we got it to be 1 by 6. And probability x less than 2y, initially we had got it 2 by 3. So we'll have to divide it by 2 by 3. Okay. So it comes out to be 1 by 4, right?
Yes, 1 by 4.
1 by 4.
0.25.
Yeah.
Ma'am, outer integral will be always from 0 to infinity.
I mean, for this figure.
Scroll up little. 1 second, ma'am. Can you please? Okay, thank you, ma'am.
Yeah. So why the limit of x is 0 to infinity? Because you can see clearly from here, right? X is varying from, x starts at 0 and it goes till infinity. So the reason of integration for x is 0 to infinity here.
Okay, ma'am.
Okay.
And why did we integrated with y first and then with respect to x?
You can do first x and then y also. So both gives you the same answer. Either you do double integral fxy dx dy, or you do double integral fxy dy dx.
Ma'am, is it not in the way, ma'am? Like now x is equal to y, so y is dependent on x, so we have to fix x, then we have to go for. It is not like that.
Sorry.
No, what I mean is now here x is equal to 2y, no, ma'am. The limit.
Yes.
So y is the dependent variable for x, actually.
Okay.
So that's why we are first integrating like that.
No. It's not like that.
Anyway, we could get the same answer.
Anyway, you can get the same answer. Yes.
Okay, madam.
Is it valid for every case?
You can do either dx or dy, or you can do dy dx. It's not a problem. It's valid for all the cases.
The limits only.
This is true always.
Ma'am, here what will be the limit for x?
So if you have to take the limit for x, let's do this. So
it would be y.
I am fixing my y. Okay. So x will vary from y to 2y.
Okay. Yeah.
And y will vary from 0 to infinity. Okay.
Okay, ma'am.
Y to 2y.
So in any problem you do of the double integral, one exercise that you can always try is, like, let's say first if you have done solved using dx dy, then try to do dy dx also, just to see like both gives you the same value. That way you'll also get to know how to take limits in different cases. So that can be a good exercise to do.
Yes, ma'am.
All right, let's move to the next problem. So in this problem, you have again two random variables. So in the previous question, we saw two random variables that were exponentially distributed. But here we have a much simpler case. We have the random variables x5, they are uniformly distributed over this region D. Okay. You have this region D and your random variables are uniformly distributed on this region. So the first question that is asked here is to determine what is fxy. So what you can do is, first thing to do is just draw the region, right? So just draw the region. You have D equal 0, 1 cross 0, 1
union
2, 3 cross 0, 2, 3
cross 0, 1
cross 0, 1.
Yes, ma'am.
So let's draw this region. So if this is your x, this is your y. So 0, 1, 0, 1 is going to be a square, right? So you have a square here. So 0, 1, it is again 1. Now you have 2, 3, 0, 1. So
no, actually, in this region, the first part denotes the x and another part denotes the y. I was just drawing the region. I just confused while solving.
Okay. So the way to interpret this region as like 0, 1 is in, like, this is for x. So think of it as x cross y. Okay, x cross y. All right. So x cross y means, so x is 0, 1 here. So you have to take this whole interval, close interval 0, 1. Okay, I took this close interval 0, 1. Then cross it with again y 0, 1. So you have 0, 1. So this gives us a whole square here. Again, union you have 2, 3 and y 0, 1. Okay. So you have this region D here. This is region D. So these two combined makes the region D. Now, what is the first question? You have to determine what is fxy, right? What is fxy?
1 by area of
So
D.
how do you find it? So in case of
1 upon area, ma'am.
in case of uniform distribution, it's quite easy, right? You just do 1 upon area of the reason D. So what is the area of this reason D?
2 units.
It's just 1 by 2. So 1 by 2 for xy belonging to this reason. Otherwise, it's 0.
Yes, ma'am.
Right? So C will be a correct answer. Right?
Ma'am.
Yes.
Ma'am, could you repeat once again, ma'am, how it is 1 by 2, ma'am? Yeah.
How it is 1 by 2? Okay. So you must have seen in the lecture that when you have
Yeah, ma'am. 1 by area. If
1 by
it is
area, right?
distributed
When you have two random variables uniformly distributed in reason D, then the joint distribution is given by 1 upon area of the reason D.
area. Yeah, but here, ma'am, two areas are given, like 0, 1.
No, this is one reason, right? I mean, this is the reason D that is given to you. Doesn't matter if it's just 1 block or 2 blocks or 3 blocks. I can have one more added here.
Okay.
I can say union of 1, 2 cross 2, 3, right? And I can have another bar over here, but it doesn't mean it is 3 different areas or something. I mean, you have to take it combined.
Ma'am, can you please explain how did this area 2 has come up?
Yeah, so basically, when you find the joint distribution of the random variable, when both are uniformly distributed over a reason, then in that case, you know that it is 1 upon area of the reason D, right? Now, your reason D here is this area plus this area, right? And what is this area? This is just one unit, and again this is just 1. So combined area is 2. So the area of the reason D is 2, right?
Okay.
So this is 1 by 2.
Ma'am,
if we have to go for the marginals, then we have to mention for the limits of x and y independently.
Yeah, you will have to mention. So like yeah, so the next question.
Ma'am, I have a doubt in the previous question.
Yeah.
Ma'am, why do we only go for element of D? Why not a particular range?
What do you mean by element of D?
I'm like in the options. For 1 by 2, there are many other.
Okay. Look over here. So fxy, it is 1 by 2 for x lying between 0 to 1, y lying between 0 to 1. But is that true? Your x is also lying between 2 to 3. But in the option 1, it is missing.
Yes, ma'am.
If you look at the second option, again it is 1 by 2, but the first block is missing, right? That doesn't cover the whole reason D. So that's why you have to go for the third option.
Okay, so ma'am, in the second option, it's only covering the
the second block, yeah.
Okay, ma'am.
The first option is only using the first block.
Okay, ma'am.
Hello.
Yes.
Ma'am, 1 by area only used in a uniform distribution?
Uniformly distributed, like two random variables, when they are uniformly distributed over a reason, then the joint distribution is given by 1 upon area of the reason D.
Okay. Okay, thank you.
Okay.
I have a doubt.
Okay.
Ma'am, in the option why is it mentioned only x belongs to D? What happened to y, ma'am?
It is written xy belongs to D.
But in my PC, it's like x belongs to D. Y is not mentioned, ma'am.
There is some
No,
display problem in the portal. That is the
yeah,
reason.
that is
Yes, ma'am. That was a
possible.
typing mistake. There was X belongs to D.
Okay, I was not aware of it. Is it for so many people?
It is for all the
Yes, ma'am. It's for all.
Yes, ma'am, for all, ma'am.
Oh, for all it is like that. Okay. Yeah, must be some technical glitch. Yes.
Okay, ma'am. Thank you.
Yeah, it is XY belongs to D. Now, the second part of this question asks you to check whether X and Y are independent. So, how do we check for the independence of two random variables?
And we find the conditionals and check if
F of
the joint is multiple of.
Joint is equal to multiplication of the marginals.
Yeah, we need to check whether the joint is product of marginals. So we have to check if fxy xy is equal to fxx times fy of y. We have to check this. Okay. Now, what is fxy? We know it is 1 by 2. Now we'll go for 1 by x. Sorry, f of x and f of y. So f of x, how do you find it?
Integral of
you have to do the integration
of x
right?
Of fxy or di.
fxy of dy. And y is varying from 0 to 1, right? So this is the figure. And for any x, like x, if x lies between 0 to 1 or x lies between 2 to 3, your y is always lying between 0 to 1, right? So,
ma'am, so here we are integrating on the limits of y, right?
We are, yes.
Okay,
ma'am. For this, we have to take the slice type of thing, like slice goes from.
I will just draw the figure here again. It will be easy to see. So you have 0, 1, and you have 2, 3. This is your y, this is your x. So we are finding fx of x, right? So we need to fix our x. We need to fix our x. So x we have here we have two cases. One is that x lies between 0 to 1, and other is x lies between 3 to 2. 2 to 3. Okay. So in both the cases, your y is always varying from 0 to 1.
0 to 1.
Right? Your y is always varying from 0 to 1.
Yes.
So this is, what is fxy? Fxy is 1 by 2, as we have seen earlier. So 1 by 2 dy, so it becomes just 1 by 2. If you integrate and take the limit, fx becomes 1 by 2. For both x lying between 0 to 1 and for x lying between 2 to 3. Right?
Yes, ma'am.
Otherwise, it is 0. Now, what happens for fy of y? So, for this, we'll have to integrate your fxy with respect to x, right?
Yes, ma'am.
And how is the x varying?
Ma'am, first it will vary from
0 to 1 and 2 to 3.
0 to 1.
And
yes. Again, you have 2 to 3. Okay. So again, you have fxy is 1 by 2. So you have 1 by 2 x 0 to 1 plus 1 by 2 x 2 to 3.
Yes, ma'am.
So this comes out to be just 1. Correct?
Yes, ma'am.
So is fx times fy equal to 1 by 2?
Yes,
so yes.
Yes, ma'am.
So what we saw is our fx of x times fy of y turns out to be 1 by 2 times 1, that is 1 by 2. And this is same as fxy of x comma y, right? So that implies x and y are independent.
Ma'am, is there a way to look at the independent case using geometrically? For example, in this case, we have seen there is no overlapping regions. So it seems that they are independent. So is this the case that if the two figures are not in overlapping with each other, then they will always be independent?
What if we have one block of square? How can you interpret that? It's not. They just represent one reason. You cannot say they are non-overlapping. They are not two reasons. If there is only one square given to you, this question can ask then also.
Yes.
In that case also, it like that could have been asked. But what you're asking is like if in this case you're saying that it's non-overlapping, and we're saying they are independent.
If we create a new square out of these two, which overlaps both the two regions, then it will seem that they might be independent because the region is being dependent.
It is possible. Like we are weighting our x, right? We are weighting our x, and your y is not depending on that. So like if I'm varying my x from 0 to 1, our y can also take any value between 0 to 1. If I'm varying my x between 2 to 3, your y can still take any value between 0 to 1. So the value of x here does not depend on y. But there can be some cases when where I change my x, your y will vary. I mean, y will be dependent on what.
But still, even if the value depends, then also we have to integrate, because if you don't, it might be that even the values are changing, but still the integration is coming out to the same, because it's the sum of those strips, right? It can come out to be the same.
Even after that, it can be independent also.
Integration we would have to do, man.
Yes.
No, I mean, some cases, in uniform cases, it can be checked, but for non-uniform, we'll have to do the integration.
Yes, ma'am.
But for uniform cases, it can be checked from the figure.
Yes, ma'am.
So if you want to look into it more detail, I will at the end of the session, I will just take you. I will just share one YouTube link that is from the previous term live session. Okay, you can just check one part of that. So there it has been explained properly.
Okay, ma'am.
So Professor Andrew was also there in the session, that thing. So you can just have a look over that part itself to understand it clearly.
Okay, ma'am.
Okay. All right. Let's move on. Now here you have two random variables x1, x2 given to you, and they are IID x. Okay, and x is a discrete random variable that has the that follows this distribution. So basically, x is taking the value -4 with probability 0.3, taking the value 1 with probability 0.2, and x is taking the value 2 with 0.5. Yes.
Yeah, ma'am. So can we upload this video, because neither the solution and anything is uploaded. So I am a working professional, and I cannot attend this type of sessions live, but it is very much needed. Means I am family man. I mean, a lot of other responsibilities. So it will be better either you upload the working solution or at least this YouTube video link.
Yeah, by tomorrow morning it will get uploaded.
But the thing is that where I get this information, because it is nowhere. It is not.
You will get it in the calendar, like YouTube one. You will get it in the calendar itself, and the slides. These slides you will get it under the supplementary content.
Okay, and the mock solution. Are you going to upload?
Yes, this will get uploaded, mock solution.
Okay, so because the thing is that for me, I go for this mock, and couple of questions I thought I am right, but that was wrong. So that will be worried me. Okay. So I cannot attend. Sorry for disturb you. Please upload it, the YouTube video. Otherwise,
Yes,
it
yes,
will
definitely.
be a big mess
So I
for
will
us.
also for right now, by tonight it will be difficult, but by tomorrow morning it should definitely get uploaded. And also I will take you, I will share one YouTube link from the last term, so you can also check the questions over there.
But
Okay,
where you
that can also
upload
be
that?
done.
Where do you upload that? The last time video?
I will share it in chat box.
Ma'am, the YouTube link
This
is
chat
shared.
box or WhatsApp group, madam?
This chat box.
Ma'am,
Okay.
I have just shared the channel link. If anybody wants, they can see that there.
Yeah, you can. Yeah, you can
Ma'am.
refer to that.
Yeah, ma'am, please do this because these sessions are very useful, but somehow we are missing it because it is not properly managed. It's like mock test solution is not updated, and some of the things.
Bi-weekly mock. Yeah,
Yes,
bi-weekly
ma'am.
mock
We still
solution has
haven't
not
received
been
mock.
uploaded.
Nothing is updated.
Even
Ma'am, we still
even the
haven't received
previous
mock solution of week 5 and 6.
Yeah, week
previous
5,
revision
6.
sessions are not uploaded to YouTube channel, official channel.
You revision session should be there.
No, ma'am, no, they are not
Can you
there.
check in the calendar?
Yeah, I have checked, ma'am.
It's not
It's
there.
uploaded on some other channel which contains a lot of ads, so it is a lot of distracting because in every 5 minutes there would be an ad. So it's not an official channel, but some other student group have just uploaded on some other YouTube channel.
Okay.
Ma'am, solution of week 5 and 6 is also not uploaded. The mock which was conducted week 5 and 6.
Okay. So tomorrow both this mock, this one and the 5, 6, they will get uploaded by tomorrow.
This is the same channel we need to refer now?
Which channel?
Mr. Jain has uploaded this link there for YouTube channel.
Oh, wait, let me see.
So, ma'am, sorry, I actually disturb the flow, but the problem is that whenever I need these sessions, why I am doing the mistakes, I am not able to find anything. And these sessions are extremely useful.
Okay, Bhattacharya, actually, links for all these sessions is available in the calendar, right? So if you want to join them live, you can join them live. It's not like they are not
So it
managed.
is not. It is not. No, so sir, it is not a case for all. Na? There is all are not student here. That means I
understand that.
Madam, this is the
Okay,
same.
ma'am, we will move on to next question, ma'am.
Yeah, please, guys, we have disposed to this.
Yes, ma'am. It's already 9 o'clock.
Please raise these
Yeah.
concerns in the discussion. It's not like.
Okay,
Can
please
we have the
hold on
confirmation?
here.
Same YouTube channel need to
It's the
refer
same
tomorrow
YouTube
morning?
channel. It's the same YouTube channel. Yeah.
Thank you. Yeah.
Can we please proceed, ma'am?
Yes, just give me a minute. Okay. So
I have a doubt in activity question. When I can ask?
Not now. Let me finish mock and then we'll go to the activity if we have time.
Okay.
So you have two random variable here. So you have x1, x2, and they are IIDX. Okay. And what do you mean by IIDX here? So they are independent. Both are independent, and their distribution follows the distribution of what x is. We are saying here, right? So x takes 3 values here, correct? So x takes the value -4, 1, and 2. And what is the probability that x takes the value -4? It is 0.3. It takes the value 1 with probability 0.2 and 2 with probability 0.5. So this is a distribution your random variable x follows. Now, the first question is find the moment generating function of x. So what is the moment, like how do you find the moment generating function of a random variable?
Probability into the function.
It is expected value of mx of lambda is
e to the power of minus.
So it is
e to the power of lambda x.
e to the power lambda x, right? So
Yes.
e to the power lambda x is nothing but basically a function of your random variable x. So, and this is expected value of function of random variable of x. This we can write it as fx of x e to the power lambda x, right? And x belongs to the range of x. Now just we have to compute the summation. So x is taking the value -4. So e to the power -4 lambda with probability 0.3, right? Plus e to the power lambda with probability 0.2 plus e to the power 2 lambda with probability 0.5. So this is the moment generating function for the random variable x, right? So this is the correct answer is option B, right? So this is quite straightforward.
And
You
the
just have to
probability is multiplied.
yeah.
Okay.
It is clear, right?
Yes, ma'am.
Yes, ma'am.
Hello, ma'am. Hello.
Yeah. Now we have the second part. Yes.
Hello, ma'am. Why here x1, x2 are given? Hello, ma'am.
Why x1, x2 is given? It will come in the next problem. This problem has second part also. So the second part says define y equal x1 plus x2 and now find the distribution of y. So if I ask you to find the distribution of y, how will you find it?
That's what we do in PMF while finding PMF.
Yes, so one is like
we can draw that table, ma'am.
Yeah.
You can draw the table. You have x1, you have x2, right? And then you have fx1, x2. You look for the range of y and then look at the probabilities. One way is that. But then there is another way
MG
to do it.
of y would be
yes.
Expected value of e to the power.
We will go through the MGF of y. Okay. So you have my of lambda. Okay. And this is expected value of e to the power lambda y. Correct? And this is what? Y is x1 plus x2. So e to the power lambda x1 plus x2. Okay. And this is expected value of e to the power lambda x1 e to the power lambda x2. All right. Now, since x1 and x2 are independent, so fx if lambda x1 is e to the power lambda x1 is fx and e to the power lambda x2 is gx, then they are also independent. And we can write this as expected value of e to the power lambda x1
into expected value
of
lambda
x2. Okay. Now, since x1 and x2 they are identically distributed as x. So what I can do is I can write this as expected value of e to the power lambda x 2 times, and this will become square. And this is nothing but mx lambda whole square, right?
Oh, yes.
Mx lambda. So
I am not understood. Whole square part I am not understood.
Whole square. Okay. So after this step, what we have done is after this step, so we know it is given to us that x1, x2, they are IIDX. Okay. So if we are saying that IIDX, I can write e to the power expected value of e to the power lambda x, and again I can write expected value of e to the power lambda x because they are IID2x, right? They are identically distributed as how the x is distributed. So this is just expected value of e to the power lambda x whole square. Correct?
Yes, ma'am.
Is it clear? All right.
Yes.
Now you have mx moment generating function of x whole square. And what is that? We have found that. And this is 0.3 e to the power -4 lambda plus 0.2 e to the power lambda plus 0.5 e to the power 2 lambda. So we'll have to do the square of this. So a square plus b square, a plus b plus c whole square you have to do, right? So you have mx lambda whole square, and this is 0.3 e to the power minus 4 lambda. So 0.3 e to the power minus 4 lambda plus 0.2 e to the power lambda plus 0.5 e to the power 2 lambda, right?
2 lambda.
Yeah, you have to do the square. So you know the formula for this a plus b plus c whole square.
This is that
A square plus b square plus c square plus 2ab plus 2bc.
Yeah, just I'm not going to just solve it completely. So you just use this formula. So a plus b plus c whole square is a square.
Can you please do it with the table method you had mentioned earlier?
Okay, yeah, I think table method is much easier for this problem, I would say.
Yes, ma'am.
Go with the MGF only if it is a very complicated expression. Otherwise, table method is easier to go with. Let's do it over here. I will just do the table method here.
Ma'am, first let's complete it now, ma'am. This method.
Yeah, this method is after this you'll have to do the square, and you look at the probabilities, you look at the value it takes, and just map it and get the answer. There's nothing.
Okay, so once we know the MGF of y, we can map it to its distribution.
Yes.
Okay.
So using the table method, you have x1, you have x1, you have x2, you have fx1, x2, then you have y, that is x1 plus x2. Okay, so x1 takes the value minus 4, then x2 takes the value minus 4, minus 4 1, minus 4 2, then you have you have 1, you have minus 4 1, you have 1 1, you have 2, then you have 2 minus 4 2, you have 1 2, again you have 2. And what are the probabilities? This was, so x is taking the value minus 4 with probability 0.3. It's taking the value 1 with probability 0.2, and it's taking the value 2 with probability 0.5. Now x1 x2 are IIDx, right? So they are also independent basically. So what will happen? Fx1 x2, this will be equal, same as fx1 fx2, right? So it will be same as 0.3 times 0.3. Okay,
product of marginals. Yeah.
Yes, product of marginal. It will be same as 0.3 times 0.1. This will be 0.3 times 0.5, right? This was 0.1 and 0.3. Yes, yeah.
It should be 0.2 and 0.3.
Ma'am, that is 0.2, I think.
Wait. One was okay.
Ma'am, 0.1 will be.
Yes,
one was with 0.2. Yeah. So this was 5. This was 0.2. Okay. Yeah. So again, it is 0.2, 0.2. You have 0.2, 0.5. Then 0.5, 0.3. You have 0.5, 0.2. Then you have 0.5, 0.5. Okay. So x1 plus x2 is what? This is minus 8. This is minus 3. This is minus 2. This is again minus 3, 2, 3, minus 2, 3, 4. Okay. So what is the range of y?
Minus 8, minus 3, minus 2.
Minus 8, minus 3, minus 2.
2 and 3, 4.
2, 3, and 4. Yes. All right. Now, what is the probability that y takes the value minus 8?
0.09.
0.09. So y is taking the value minus 8 only for one case. That is when x1 is taking the value -4 and x2 is taking the value -4. So this is for 0.09. Okay. Now, when is y taking the value -3? It is for 0.1. Okay, so this is happening for this one case, second, two cases, right? So one is for this and other for this. So it becomes
0.12.
Yeah, 0.06 plus 0.05. Sorry, saying 0.06, 0.06.
It would be 0.12.
0.12. Yeah.
Next.
Now y is taking the value -2, so it is taking -2 in two cases. One is -4 2 and other is 2 minus 4.
0.3.
Right, so 0.30. Now y is taking the value 2 when? So only for one case. So this 1 1, so 0.04. So you have 0.04. Now it's taking the value 3 for two cases. So one is this and other is this. So 0.10, so basically 0.2. Now it is taking the value 4 for just one case, so 0.25. So just add if it gets added to 1, 9, 10, 11, 15, 5, 20, okay. 2, 4, 7, 8, 9, 10. Yes, so it gets added to 1. So you can just check over here. So y is taking the value -8 with probability 0.09. Then 3 with 0.12, 2 with 0.30.
First option.
0.30. Okay, first is correct, is it? Okay. So you just check whatever you have got and just check from the option. So you'll get option 1 to be correct. I hope this method is clear
Yes,
to all.
ma'am. Yes, ma'am.
Yes, ma'am.
Yeah, let's.
Ma'am, can you show how you can connect from the moment to the probability distribution?
Okay, so for that you'll have to square everything. So if you square it, you will get.
We will do this, ma'am. This is.
Yeah, you can do this part.
Only just a squaring.
Okay, can you try doing it? It just square.
Yes, ma'am.
Yes, ma'am. It is same.
It is
Please
same.
move
If
ahead.
somebody has tried, you can just.
Ma'am, we can just directly see it is the same thing. Na? E to the lambda x1 into e to the lambda x2. We can also see it from here. Suppose we want -8. So that can come only when x1 is -4 and x2 is -4, right? And probabilities will also be multiplied correspondingly from expected values only. So that thing also can be seen here rather than drawing the table. That can also be thought from here also, right?
Exactly, we have to just compute in our mind with it.
The powers just have to be added to get -8 in the power. We have to
added. Yeah.
-4 into 2. Yeah. And move to next question.
Yeah, all right. So next you have okay. Suppose 60% of adults in the age group of 45 to 50 in a country are male. All right. So you have the male population, which is 60%, and 40% are female. Now, the height of adult males in that age group in the country is normally distributed with mean 160 and variance 25, and that for female it is normally distributed with the mean 150 and variance 25. So let's define two random variables here. So
excuse me, ma'am.
Ma'am, same problem is discussed in the week 5 tutorial, ma'am.
Okay, so do you want me to skip this part?
Yes, ma'am. Ma'am,
No,
there are
ma'am.
many questions.
No,
ma'am,
ma'am.
there are many questions discussed earlier.
Ma'am, it will be very much good if you discuss it.
Okay, let's discuss this. So let's take this to be X and
gender G.
Yeah, okay.
This is a discrete
X the height, ma'am, and height of the person, and G be the gender, which can take two values.
Let's take X to be M and F. Okay, so the probability that your random variable X is M is 0.60 and it is F is probability
0.40. Yeah.
Now the second information that is given to you is like given.
And we can represent M and F by 0, 1, so that.
It's okay. We can write it M and F. So given that your X is M, your the height of adult males is normally distributed. So let's define another random variable Y that represent height. Okay, so height Y given X equal M. This is normally distributed with mean 120 and variance 25. And for the female, or when X is F, it is normally distributed with mean 150 and variance 25. Now the question is, if the height of a randomly selected person is 170 centimeter, now you pick one person from that age group and you have observed the height to be 160 centimeter. Then what is the probability that the selected person is a male? So you have to find what is the probability that the selected person is a male
equal to M,
given the height
Y
of the
equal to
selected person is 160.
60.
Okay. So how can you do this?
Excuse me, ma'am. We can do it either way. Also, that we will find Y given X equal to male for 160 and Y given X is equal to female for 160, and then comparing it.
Sorry, can you repeat?
We can do it in the way like Y given X is equal to male is a normal distribution. We will find the value for Y is equal to 160 and then comparing it with the female.
Comparing it with female.
Yeah, which one has higher probability?
But we have
but if you want to like find Y equal to 160 also, now you will have to find both of them separately, then add them.
Yeah. We have to.
You will have to find and then add. Yeah. So this is basically probability X equal
Bayes
M.
rule.
Yeah, Bayes rule. Y equal 160 divided by probability that Y equal 160. Right? And this numerator part, I can write it as F
Y equal to 160.
Y given X equal M of 160 of Fx of M divided by Fy of 160. Right.
Ma'am, we do not know Fy, right?
So Y given X equal M. We do not know Fy, so we'll have to find Fy. So okay, in the numerator part, this you know, Y given X equal M. This follows a normal distribution with mean 160 and variance 25. So this you can find it from there. Fx of M you already know. And how do you find Fy of 160?
Ma'am, can you pause for a moment?
We can write it as.
Can you explain this?
Yes.
How you have written this equal to P, X equal to M, comma Y equal to 160, and how you can?
It's just conditional probability, right?
Yes,
it's just X equal M.
Okay,
comma
it is
Y
joined
equal
by
160.
joined by
Joined by marginal.
Yeah.
Right.
Then how have you
again this joint can be written like this. You know this property that Fxy
making factors.
Yeah, factorization. Yeah. So Fy given X of Fx of X, and this is also same as Fx given Y of fy of y, right? So I have written this as fy given x of fx of x, correct?
This is Bayes rule already taught.
Bayes rule, yeah.
Okay, you have turned it into this because we are given the normal distributions of
we already know. We already know that it is normally distributed.
So to convert it into that form, you have written like this.
Yes. Now we need to find fy of 160. Okay. So fy of 160, basically fy of y. So fy of y is what? Probability that y equal 160 given x equal m into probability x equal m plus probability that y equal 160 given x equal f into probability that x equal f. So just all the information is already given to you in the problem. Just do it and just compute it and just substitute it here. You will get your answer. Can you do it after this?
Yes, ma'am.
Yeah?
Yes, ma'am. Yes. Now it's the only the calculation.
Normal distribution, ma'am. Can you just solve for that normal distribution?
Ma'am.
Which normal distribution?
F of y where x is equal to male for 160.
It is a formula 1 upon.
I will just write one formula here. Wait.
This is a variance or a standard deviation? It's a variance.
Variance. It is variance. So fy given x equal m of 160. So you see that this follows a normal distribution with mean 160 and variance 25. So this is going to be 1 upon sigma. So it is normal with mean 160 and variance 25, right? So it becomes 1 upon sigma under root 2 pi. So sigma is 5 under root 2 pi e to the power minus 1 upon 2 x minus mu, right? So this x here is 160. So 160 minus 160 divided by sigma whole square. So this is what you get. This is just one part. You can similarly solve for all this part and get the answer.
Into the probability x is equal to m.
Yes, that is there. I'm just writing it for this. I'm just solving this.
Excuse me, ma'am. Can you, ma'am, please explain it theoretically? What does it mean?
What does it mean? So, see, in the problem, you
had
to find...
I'm talking about fy given x is equal to male of 160. What does it mean?
So, it means that given you have observed a male, what is the probability that the height is 160 centimeter? That's all.
So, ma'am, directly we can't conclude with that.
Directly you conclude from what?
And from this that this is the ratio for male.
You don't have to find the ratio, right?
No, ma'am. We have to compare for the which has better probability.
No, we don't have to compare anything here. We have to compute the probability. Like, what is the probability that given the person you have selected, have chosen, the height is 160. What is the probability that the person is a male?
Okay, so my question is just like this. Like we have given y given x is equal to male is a normal distribution. So my question is we can't get the answer from this only.
How will you get the answer from this?
Ma'am, because we are getting for the value of 160 for male. So why it is not the answer? I'm saying
because the question is this. Question is not this. Your question is this. This is what you have to compute. Right? You don't have to compute this. This is just the part of.
This is what I want to.
You have to find this probability x equal m given y equal 160.
Yes, ma'am. That is what I am asking. That please explain it theoretically. What is the basic difference? between these
the first what you have to find in the question is, like, given the height is 160, you have chosen a person, you have seen a person and you observed that the height is 160. Now you want to know what is the probability that the person you have chosen is a male. Okay, the person you have seen is a male. Now what this says is that given that you have observed a male, now what is the probability that the height is 160? There's a difference, right? They're not same.
Okay.
So after this, just compute all this conditional probabilities and you will get your answer. Okay. Let's move to the next question now. So we have, I think, 6-8 more questions. Okay. So the question says here, let the joint PDF of two random variables x and y be given as fxy 3 by which is equal to 3x squared by 2. X is between -1 to 1, y varying from 0 to 1. Now the question is, what is the value that probability? What is the value of probability x greater than y? Right. So so the first thing, what do? We just plot the figure. We'll plot the figure here. So x lies between -1 to 1. -1 to 1. Y lies between 0 to 1. Okay. X is greater than y. So you have x greater than y in this part. This reason is clear?
Yes, ma'am.
Yes. Okay. Now how do you find the probability? Can somebody tell me?
Ma'am, by fixing
1 by
y or x.
minus a.
Y limit should be 0 to x and x limit should be 0 to 1.
Y limit should be 0 to x and x limit should be 0 to 1. Okay, right. So to find the probability, we'll have to integrate, right? So this is 3 by 2 x square dx dy, and x is varying from, so I can do x. If you are fixing x first, I will do y. Okay. So y is varying from 0 to x. So let's draw this line. Y is varying from 0 to x and x is varying from 0 to 1. Okay. So okay. Sorry. The limit is clear, right?
Yes, ma'am.
Yeah, okay. So you have 3 by 2. I can take 3 by 2 outside, and you have x square d by here, okay? And dx.
Ma'am, the range of x here is -1 to 1 in the question.
The range of, yes, the range of x is -1 to 1, but the range of y is 0 to 1, right?
Okay.
Ma'am, to find the range of y, we draw a perpendicular line, and to find x, we draw horizontal line. That is.
Yes, you can do that, yeah.
And we will take when we will log the y, the limit will be from x to 1.
Limit will be from x to 1, right?
Okay.
Okay. So you can try to solve this. So this will come out to be 3 by 2. So this is x square and this is x. So it will become x cube. Become x cube dx 0 to 1. So it becomes 3 by 4 x to the power 4 by 4. So it is 1 by 4. So 3 by 8. So 3 by 8 is the answer.
Ma'am, what if we interchange the value of the over the first integral we write 0 to 1 and on the second we write 0 to x?
Sorry, I did not get what you just said.
I mean, like the very first line, the signs of the integral. What if we like swap them? We write 0 to 1 over the first.
Okay, we write 0 to 1 over the first. Okay, you are saying in place of writing y is from 0 to x, we write y is 0 to 1.
No, we write x is equal to 0 to and over 1. Can't we write that?
You can write that, but when you integrate, you will first integrate with respect to y.
Actually, we have to eliminate the variable.
Yeah.
Yes. After that, we will have to put the value also.
First, you try to bring it to one variable and then you put the values.
Ma'am?
Yes.
Ma'am, integration of x cube x square dx x cube dx. X cube dx is equal to x to the power 4 by 4, I think. X to the power n plus 1 by n plus 1.
Yes, x to the power 4 by 4, right. So this is what I have done here, right? X to the power 4 by 4. So you take the limit 0 to 1, it becomes just 1 by 4.
Okay.
So 3 by 8 is the answer. Now in the second part.
Just 1 second, if you could scroll up.
Okay.
Am I wrong, or is the first line supposed to be dy dx?
It is all right. I mean, you can write it dy dx, you can write it dy dx dy. No, it's not a problem.
But based on the integral, and you've written the limits of y.
We have to take care of the limits only.
I have
when you integrate over y,
you
just take care of the limits. That's all.
It doesn't matter if I write the limits of y.
Okay, just for our sake, that how can we understand it?
I thought that the dy has to be close to its own limits, and then dx. It isn't that way?
No, it's not a problem. You can write according to your convenience. It's all right. So like fx integral fxy dx dy gives you the same value as what integral fxy dy dx will give.
No, what I'm saying is the limits
writing
first x. Yeah, x is written first, and then limits of y. Then
it's
should it be like y dx?
You can write this as You can write this as 3 by 2 x square dy dx. No problem. Both are right.
Okay.
So if you're more comfortable writing it in this way,
x is the range.
Stick to one thing.
Ma'am, the value of x is given from -1 to 1. So, but y cannot take negative value. So when it takes value between 0 and -1, y takes negative value. So that's why that reason is not permissible, and any other reason is not allowed.
Yes. Because y is from
it's
0
just
to
the
1.
extra alleyway that is given.
Yes. Now, but if you look at the second part of it, so the second part of it asks you to find the probability that mod of x is greater than y. So when mod of x is greater than y, this is our mod x. This is your 1, this is your -1, this is your 1. So mod of x greater than y. So this is this reason. This plus this.
Now we have to integrate it in two parts.
Now we have to integrate in two parts. Like this part, we are already done 3 by 8. And in this case, you can also just multiply.
By the way, the graph is symmetric. The second one would also be 3 by 8, right?
Yes, 3 by 8.
Yes.
It would be 6 by 2.
Ma'am, how come the minus region becomes x is greater than y?
Now the function is mod x greater than y.
Mod of x greater than y.
Okay, madam.
Yeah. So
from symmetry we have
I'm not understood. Minus region.
Sorry. What
Ma'am, minus region I not understood.
Why?
No, ma'am, can I explain, ma'am?
Yeah, please go on.
No, actually, minus is mod means irrespective of whatever the sign is, so we can consider that region. So you just remove the minus sign and check. Now the x is greater than y, no? Okay, if it is not, I'm sorry.
Yeah, also what you can otherwise do is you just take a point -1, 0. Okay, here x is -1, but in mod x it becomes 1, and 0 is y. Now obviously 1 is greater than 0.
Yeah, that is a better explanation. Yeah. So you can take the points and just check for the reason. So because of symmetricity, again, you see that since this was 3 by 8, even this will come out to be 3 by 8. So it just becomes 2 times 3 by 8 and it becomes 3 by 4. So your answer will be 0.75.
How did we get 3 by 8?
3 by 8 from the first problem. We got 3 by 8 from the first problem. Now, when you look at the second,
whenever mod x is given, we will take both region. Whenever mod function is given, we will take negative and positive both region.
It depends on what is the range of, what is the support of xy. It's not like you have to take both reasons or something like that.
Ma'am,
Yes.
I have one doubt in the calculation of the 3 by 8 part.
Okay.
In the integration part, how did we get 1 by 4 from x cube?
No, we got like we have to integrate x cube dx, right? And you get x to the power 4 by 4.
But
So
ma'am, we
this-
had x square first, now. So how did we get x cube from x?
X cube we get from here. Dy, you integrate dy, and you get, if you integrate
Oh yes,
dy.
yes, understood, ma'am.
Understood? Yeah. Okay, we'll move to the next
But
problem.
this requires lot of calculation, ma'am. Will you be able to finish it by within 1 hour, ma'am, all this?
No, anyways, this has more questions because I've also taken it from other mock.
Okay.
So what the number of questions that you had seen in the quiz one?
And would you be uploading
would
the
be
solutions
same.
for these two mocks by tomorrow?
Yes, we'll be uploading. Yeah.
Ma'am, please also upload the solution of week 5 and 6 along with
Yes,
this, no?
along with this, we'll also upload that one.
Okay.
You were telling something else, ma'am, about the mock questions, number of mock questions.
Sorry. Is somebody saying something?
Before that, you were telling about the number of mock questions also.
Number of mock questions. So the number of questions that you have seen in quiz 1 will be same as even in quiz 2. Number of questions will be kind of same only. In this mock, the number of questions are more because I've taken the problems from both the mocks. So that's why more problems here.
Ma'am, the pattern would be almost the same like this mock.
Pattern will be same like this mock. Yeah.
Ma'am, will the formulas also be given, like all
The formula
distribution
file, what you have seen in the quiz 1, the same formula file will be there for your quiz 2.
Ma'am, you would not be updating the formula file.
Formula file is already there on the portal.
Yes, ma'am, but it contains formulas from week 1 to 4.
So only those formulas will be available.
Formulas for this week, this term will be available.
Like the formula sheet contains distribution, guys, not formulas basically. So these are the different distributions, and the same distributions are being used, just concepts have been added, right? So no new distributions you got to know. So those formula sheet only contain distribution formulas like expected value of different distributions.
There you already have for the continuous distribution.
We also get like Chebyshev's inequality and all those inequalities in there. Like in the previous term, they also got CLT and Walras's law of large numbers. They also got that in their formula sheet for quiz 2.
A new formula is already given. You will check.
Okay.
Ma'am, actually, what will be given to us, please provide it us before the exam.
Yes.
We can relook that.
Sorry.
Basically, what I'm saying that before the exam on 20, provide us early such that we can relook what the formula sheet, that what is being included, what is being.
Yes. I am sure
the
that
formula sheet is already there on the
portal. It's actually available on the portal.
Yeah, and there is a separate
gentlemen, can we move forward?
There's a separate download called formula
all
sheet.
These questions can be addressed in the chat mode also, no?
Apart from this, just a single question that in the mock one there were the questions like the list concept.
No, that kind of question will not be coming.
Okay.
Yeah.
What kind of questions?
Like select the options that you are having to solve the problem. Okay. Let's move to question number 7. So it says you have now you have two random variable x and y. So the random variable x denote the retailer's retailer's daily cost, and y denote the daily sale. Okay. And their probability density function is given in this fashion. So fx of x is 1/2 e to the power minus x by 2, x greater than 0, and fy of y is e to the power minus 5, y greater than 0. So this is how x and y are defined. And assuming that x and y are independent, and your another random variable p denoting the daily profit of the retailer, the first question that is asked is like write p in terms of x and y. So p denotes the daily profit, and we know profit is sale price minus cost price, right? So daily sale minus daily cost. So it will be just y minus x, correct? So your correct answer will be p equal y minus x. Now the second question in the same line, it's asked what is the probability that retailer's profit of the day is greater than 0. Okay, so can somebody tell me how to frame this problem, the second one? What exactly do we have to find?
P of y minus x
is greater than 0. Probability that p is greater than 0.
P of y minus x is greater than 0. That is y is greater than x.
Yeah, correct. So it is probability y greater than x. Now to find probability y greater than x, the same previous problem. Okay, so you have y greater than x. This is y equal x, y greater than x, and x is greater than 0, y is greater than 0. This is the range for x and y. So x is greater than 0, this y is greater than 0, right? This is the figure. And you have to find what is the probability y greater than x. So what is the range should we take?
The x should take range from
range
0 to y.
For x to infinity.
Y to infinity for x, man. Y to infinity for dy.
Okay, so if I'm fixing my x first, so y will vary from x to infinity, and x will vary from 0 to infinity. Okay.
Yes, ma'am.
And since x and y are independent, you can just do the multiplication of fxx, fyy to get the joint distribution. So it will become double integral e to the 1/2 e to the power minus x by 2 e to the power minus 5, e to the power minus x by 2 e to the power minus 5 dy dx. Okay. So can you solve it after that?
Yes, ma'am. Yes, please.
Yes, ma'am.
Yes, ma'am.
Okay.
Actually, I want to know that if we integrate x first, then the limit will be from 0 to y, right?
Ma'am,
Then the
how
limit
to
will be from 0 to y, right?
Okay, okay.
formula to integrate e to the power minus 1 by 2, ma'am, plus 1 or divided by minus 1 by 2.
You're talking about what?
No, integrating, ma'am, e to the power minus x by 2,
I think
ma'am. Just
integration is
divide by
greater.
minus 1 by 2.
Opposite.
So the power of
I'm
e is not
asking you,
changed
ma'am,
when integrating,
while
and the
integrating.
coefficient of x it is divided by.
Sorry, I'm not able to understand what you're saying.
X will vary from 0 to y.
X will vary from 0 to y.
And y will vary from 0 to infinity.
Y is
You can
varying
take it
from
either
x
way.
to infinity. And x is varying from 0 to infinity. And the other way to take is you can take x is varying from 0 to y, and y is varying from 0 to infinity. This is also okay.
How can both be same? Because
see, if I'm fixing my x first,
The limits of x are in terms of y,
so
right?
x is
When you're
varying from
integrating it.
0 to y. Okay, we are fixing your x first, then y is varying from 0 to infinity. Now if you are fixing your x, okay,
okay, ma'am, I
if you're
got it.
fixing your x, then y is varying from
X to infinity.
yeah, x to infinity, and x is varying from 0 to infinity.
Yeah, ma'am. Okay, thank you.
Ma'am, could you please repeat the previous part, that y minus xp is equal to?
Y minus x. Yeah, because you have to find what is the probability that retailer's profit of a day is greater than 0, right? So profit is greater than 0. Profit is given by y minus x. So basically we want probability y minus x is greater than 0. So y minus x greater than 0 means y is greater than x. So
this first part, p equal to y minus x. How we get this?
Because P is daily profit. P is just the daily profit. And what is profit? Profit is you know from the maths that profit is. Yeah.
Can you finish the calculation to the last?
Sorry, can you repeat?
Yeah, the calculation, right? It is 0 to infinity kind of thing.
So e to the power minus infinity will turn to is 0. So it will just come up when you put the limits, right? And when you put infinity in the limits, e to the minus infinity will become 0.
Can you please write it, ma'am?
Ma'am, answer is 1 by 3.
Can we have the madam answering the question, please?
Yeah, wait. Yes, the correct answer is 0.33. Yeah. So wait, I will write down the limit for both the cases, okay?
Actually, there are two cases. E to the power infinity is infinity, and e to the power minus infinity is 0.
Yeah, wait, let me write. So the first case I'm writing, fix x first. So once you're fixing x, okay, so you're fixing your x, this one, this vertical line you're saying here, okay, this one. Then it turns out to be fx fy dx dy, where y is varying from this x to infinity and x is varying from 0 to infinity. Okay. Now the second part, when I'm fixing my y first. So if I'm fixing my y first, if I'm fixing some y, my x is varying from 0 to y. So again, you have fxy dx dy. So your x is varying from 0 to y, right? So 0 to y, and y is varying from 0 to infinity. So you solve both of these and you will get the answer to be 1/3. The answer will come out to be 1/3. And this fx fy, since x and y are independent, this fxy is just fx times fy. Okay. So you can use this and just put the limit properly and calculate.
Putting the limit properly is the only question, man, because there is the main problem.
That's why you have to learn it properly. How do you put the limits? You need to practice a lot.
No, I got to practice a long time back, in fact. But in between only one step I am missing, kind of thing now. So,
okay. What
every
is that?
question? Yeah. No.
And when you fix your x first, and you take your integral across the whole range of y, that means you have to keep your y outside the integral and integrate with respect to x, right?
Yes.
So when you put x first, you integrate with respect to x.
Okay. So in this case, what I will do, I will integrate first with respect to y. So I will keep y first and then x. I am fixing my x, so I will integrate first with respect to y. Fixing my x means, so I'm fixing x. So if you can see that fixing x means I am drawing a vertical line. So if I'm fixing some x, my y is varying. So first I can integrate with respect to y. Okay. So once you are done integrating with respect to y, you can integrate over x. Now in the second case, if I'm saying I'm fixing my y first. So if I'm fixing my y, you see that your x is varying. So you fix your y and you first integrate with respect to x, and then you integrate with respect to y.
Okay, ma'am. Okay. Yeah, clear.
Is it clear?
In either of the case, can you give the next steps kind of thing at the level of 10th class student, ma'am?
Can you repeat?
In either of the cases, the answer will be 1/3. I understood that one. But in between, what are the steps would be? Can you give those steps at class 10 level standard kind of thing, please?
Class 10th level standard. I didn't understand what do you mean by class 10th level standard?
I have done these questions so long back kind of thing.
Okay.
I mean, like you actually have skipped all the, in between steps and all like that.
Yeah,
I'm struggling with the in between steps only. And the question changes from this one to something else. I'm not able to get the right way of putting it up.
Ma'am,
so many solutions are available. Like so many sessions have been conducted. You can go through the live sessions, and they have solved so many such questions. So you will get the idea how to solve integrals from there. So the problem if you have in solving integral, that cannot be like solved in stats class.
I'm
That's
telling
a maths
you,
question.
I'm telling you, this is a maths question, and I have done my maths a long back. Means most probably more than decade.
We understand, even though I solved, so maybe in the last you can ask, because all are waiting just to get the question solved. And,
right done. Thank you. Yeah,
online calculators you can use. You can use online double integral calculators. Lot of calculators are available. They will show the steps also.
Please continue, ma'am.
Work, for example.
FXFY.
But they will not be available in exam.
So.
Yeah, just for your understanding now.
FXFY is e to the power minus 5. Okay. So this is by 2 e to the power minus x by 2 e to the power minus y. Okay. dy. This is dx dy. So first I will integrate with respect to x. Dx dy. 0 to infinity.
Anandji, can you please mute yourself?
And after this, you will have 1 by 2 e to the power minus y. Okay. And if you integrate this, minus 2 e to the power minus x by 2, and x is varying from 0 to y. Okay. And this is what? This is minus 2 e to the power minus y by 2 minus e to the power 0, that is 1. So 1 minus e to the power 2. Then you have e to the power minus y by 2 dy.
Madam, your voice is not coming.
Yes, ma'am. I think we lost you.
Yes, ma'am. I think it's a network problem.
Neither her screen is moving also.
Am I audible?
Yeah, we lost your voice in between, ma'am, completely.
Oh, okay.
Yes, ma'am.
Okay. I was saying that we can stop here, right? I mean, after y, you can integrate.
Yes, ma'am. Yes, ma'am.
Okay. Let's move to the next question. It says, from past experiences, it is known that the number of tickets purchased by a person standing in a line at the ticket window for a movie follows a distribution that has a mean of 2.4 and standard deviation of 2. So let's denote this random variable by x. So let's denote x as number of tickets purchased, by a person. Okay. And what is given? It is given that this x follows a normal distribution with mean 2.4 and standard deviation 2. So this is 2 square.
Hello, ma'am. Could I please interrupt here?
Yeah.
Is in the question? Is it mentioned that each of the samples follow a normal distribution in the question? Because that's where I got confused.
Okay. Sorry. Yeah.
No,
It's not mentioned. It's not mentioned.
Thank you.
Sorry. Yeah. Thanks for pointing it out. So it just given that
I am having problem in assuming random variable. I am having problem
in assuming
so
random
how
variable.
we will assume random variable?
So
Yes.
see here, it was it is given that the number of tickets purchased by a person standing in a line, it follows distribution that has mean 2.4 and standard deviation 2. So I just said, let's say number of tickets purchased by a person is denoted by the random variable x, because its mean and standard deviation is given to us. So I can write expected value of x to be 2.4 and standard deviation of x to be just 2. Okay. Now suppose that few hours before the start of a movie, there are 100 persons standing in the line to purchase tickets. So you have the ticket counter, and just few hours when the movie is going to start, there are around 100 persons standing in the line and they want to purchase the tickets. But if only 250 tickets are remaining, what is the probability that all those 100 persons, so if you have all this 100 persons over here, so what is the probability that all of these 100 persons will be able to purchase the tickets they desire? Okay, so let's say person 1 wants to buy 2 tickets, person 2 wants to buy 3 tickets, person 3 wants to buy just 1 ticket, and so on. So you have total of 100 people standing in the queue, and you want to find the probability that all these people should be able to purchase the number of tickets they want to buy, but only 250 tickets are remaining. So what probability do we have to find? We have to find that all these people, let's say if I'm saying this x1 denote the first person standing in the line, x2 denote the second person, and so on. So it can go till x100 because we have 100%. So if you add, so okay, so basically you are interested in what is the probability that 100% will be able to purchase the tickets. So probability that this x1 number of tickets, so okay, instead of writing first person, write number of tickets
purchased by first person.
Purchased by first person. And so on. Okay. So you have to find the probability that x1 plus x2 plus up to x100 should be less than equal to 250, right?
Yes.
Because this shows that the total number of tickets that they all buy should, if that comes out to be less than equal to 250, it means everyone are able to buy the number of tickets they desire. Okay. So how do we find that? Yeah, Kaushik, do you have any doubt?
Yes, ma'am. Here I have another doubt. Should we not have a lower bound as well? Because if we want all the 100 people to buy, get the tickets, then should it not be at least 100 in the total number of tickets bought? Because if I'm assuming that the thing, the upper bound, then here it could be from minus infinity to 250, right? And which cannot be negative.
Yeah, it cannot be negative. I mean, I'm explicitly saying that x1 denotes the number of tickets purchased by first person and cannot be negative. So as long as we are adding the positive numbers, it cannot go to negative.
So should we not have a lower bound as well, like at least 100? Because we want all the 100 people to buy tickets. If it goes down,
maybe somebody is in the queue and they don't want to buy the ticket. So it's just possible.
Right. So if without the lower bound, then we are assuming that this sum can be from minus infinity to 250.
If we were interested in the lower bound too, we would have said something about the lower bound. We would have said what is the probability that all the 100% standing in the line are buying at least this number of ticket, but less than this number of ticket. We should in the question itself it should have been given.
Yes, so but that's where I got really confused when it said that all 100 should buy the tickets. I mean, had it been said that all the tickets had to be sold, that's one thing. But it's saying that all 100 people have to be able to purchase the ticket, and that's where I thought it requires a lower bound. I mean, I do get the answer. Answer is FZ 0.5 with the upper bound, but the point is without the lower bound, how do we guarantee that all 100 people will get to buy the ticket? That's what I think is a confusion, at least in my head.
Okay. So if we were interested in also knowing the lower bound, it would have definitely mentioned the problem. But here we are just interested to know that what is the probability that all those 100% people standing in the line, they are able to purchase the tickets. So it means if we add the total number of tickets that they have purchased, if it comes out to be less than 250, that is what we want. So this is.
Can I ask you one thing?
Yeah.
Yeah, it's not like related to this CLT thing only, but like from WLLM. That is like for if the no bound is mentioned, upper bound or lower bound, and in the question it's like the difference x bar minus mu, that is mentioned at most or at least. So like from there, can we do like if it's at most, then it should be like the upper bound, or if it's like that.
Okay, we have a question like that. So I'll come to that question again, because we have 2, 3 questions like that.
Yeah, and is like, will this session be recorded? Like I came late.
This session is already getting recorded.
Oh no, like will it be uploaded? Like,
it will be uploaded. It will be uploaded.
Link in the calendar. So
yeah, it will be uploaded.
Okay. Thank you.
Okay, so this is what we have to find. Now, how do we find it? So we can use CLT here, right? So what does CLT says? It says probability that you're using CLT, you know that this S minus expected value of S. So it will be N mu divided by sigma under root N. It follows the normal distribution with the mean 0 and variance 1. And what is S? S is this x1 plus x2 plus up to xn. This mu over here is just expected value of x, and sigma is standard deviation of x, right? So we would like, we want to bring this, like put this in the CLT form, in this normal 0-1 form, so that we can get the answer, right? So it will be probability that this S, what is N, N here?
100.
N is 100, and what
number
is
of
mu?
samples.
2.4.
2.4. So I will multiply this. And what is sigma?
2.
It is
2. Root n, again it is 10. So the same thing we'll have to do on the other side. So it is 250 minus
240.
Minus 240.
240. Is it
divided by 20? Yes, ma'am, 240.
Yeah, 240. Yeah. Okay. So this becomes probability Z less than equal to 0.5.
0.5.
Answer is given wrong in the.
Wrong answer is given, ma'am. I was getting so much confused.
Where the wrong answer is given?
In the portal, ma'am.
In the portal.
In mock 2, the answer is wrong. I think the mock 1 has the right answer.
Yes, ma'am. In the mock 1, the answer is right, and in the mock 2, it is wrong.
Okay.
So in the mock 1, we have to put FZ value, but.
Okay.
So can you confirm this is the right answer, ma'am, which you have shown here?
Yeah, this is the right answer.
C answer is correct, right?
C is correct, yeah.
Excuse me, ma'am, can you please tell a trick that how to identify that this is a problem from CLT?
This is a problem from CLT. Okay.
Like how to identify from the word problem?
So like in weak law of large number, what do? You have to get the bound there, right? When you try to get the upper bound or lower bound. But in case of CLT, you try to approximate the probability. and the CLT says that if you have large enough sample size, any distribution you take, it goes to the normal distribution 0, 1. So since here you had no information about what your X follows, or like what distribution your random variable follows, but you have large enough sample size, and in this case it is 100, you can say that like it will like,
okay, ma'am. What I had understood, like if we know the mu and sigma,
okay,
we can conclude that we have to change this to the normal, then we will solve it using CLT.
If there is no information on the distribution, and if the sample size is large enough, first of all, like large sample size is necessary. The distribution can be anything. If it is any distribution, if the sample size is large enough, it will eventually converge to the normal 0, 1. But if the sample size is small, then you cannot do that.
Okay, ma'am. Ma'am, we can also get the problem like we have given the distribution and then we have to convert it to the normal for the CLT.
Yes, yes, yes.
Okay, okay. Then what we will identify? Like the sample size?
Like if you don't know, like in this case, just you frame the question and you saw probability x1 plus x2 plus up to x100 should be less than 250. But after that, how will you proceed? You don't know what, you just know what is expected value of x1, expected value of x2, up to expected value of x100. Apart from that, you don't know anything. So CLT seems like a good way to go for that.
Ma'am, how to understand it is normal with 0, 1?
This normal with 0, 1, this is what CLT says, right?
It's a standard.
S minus n upon sigma root n is normal 0, 1.
Ma'am, this may be normal with 0 sigma square also, no?
Then the sigma will not be in the denominator.
No, this is S minus n mu upon sigma upon root n.
That is why it is normal 0, 1, ma'am.
It is normal 0, 1.
Can we solve it without normal also?
How will you solve it?
Without dividing by sigma.
Without dividing?
By sigma.
No, it can't be.
Then what happens?
Then it will be normal with 0 sigma square.
Okay.
We don't have solution for
then what will you do?
The other formula without.
Maybe in your case, the sigma value of sigma was 1.
See, we already have for the standard normal distribution, we already have all the values of the probability. So that is why we try to convert all this problem of normal with mean, mu, variance, sigma square to normal 0, 1. We standardize it. Otherwise, calculations are very difficult to do. So it's much easier this way because we have the values with us and we can directly find out the answer.
Ma'am, in my case, I able to do this question, but the region, the shaded region, either it is talking between the bounds or just the away from these bounds. So that is being confused. Either I should take 1 minus fz of 0.5 or fz of 0.5. That is the
1 minus f. So here we got z less than 0.5.
Yes.
So if we have this normal 0, 1 and we have 0.5, so basically we are interested in this, right? So this is FC of 0.5. 1 minus, okay, yeah. Yeah, who was that?
Yeah, it was me, ma'am, Kanishk.
This is FC of 0.5. Yes, go on.
Ma'am. Hello, ma'am. Here x1, x2, x3, all are IID.
All are IID. All are IID,
okay.
yeah.
That's why
That's why we are using CLT here.
CLT here.
We are able to use it here.
Okay.
Ma'am, the answer in the portal is showing as 1 minus x.
Yeah, I got to know that. So that is wrong. We will change that on the portal.
Okay, ma'am.
Okay.
Ma'am, can we move ahead? This first part is understood.
Yeah. So we have 4 more questions we have. All right. The next question is for the weak law of large number. Here we have a sample size of 50. Okay. So we have n equal 50. And we are saying we have collected a random sample from a population with standard deviation of 10. And we have a population whose standard deviation is 10. Let A be the event that the sample mean x bar is within 4 of the population mean mu. That is, so you have an event defined as A equal mod of x bar minus mu less than 4. This is how the event A is defined. So they, like in words, it says sample mean x bar is within 4 of the population mean mu. So you can view it like this. So you have the population mean mu, and within 4. So within 4 again it is mu plus 4 and mu minus 4. So the sample mean is within 4 of the population mean, right? So population sample mean should be there. So this is nothing but mod of x bar minus mu is less than 4. This is our event A. So this is what has been written here. A is mod of x bar minus mu less than 4. Now the question is, find the lower bound on probability of A using the weak law of large numbers. So what does the weak law of large numbers says? Weak law of large numbers says that probability mod of x bar minus mu less than delta is greater than equal to 1 minus variance of x bar upon delta square. Correct?
Yes, ma'am.
So what is delta in this case? Delta in this case is 4. So you have probability mod of x bar minus mu less than 4 is greater than equal to 1 minus variance of x bar divided by 16. Now you have to know what is variance of x bar. So what is variance of x bar?
It is sigma square by n.
Sigma square by n, right? So you have sigma square by n. And what is sigma square?
100.
100. So 100 by n.
15.
N is given, is it? 50. So you have just 2. So this is 1 minus 2 upon 16. So 1 upon 8.
7 by 8.
And becomes 7 by 8.
7 by 8.
So an lower bound on probability of A. So it is 7 by 8. So the correct answer is 7 by 8.
Here mu is not given.
But mu is not needed also. Where are we going to use the mu? You just have to find a bound on the probability of A. Event is defined. And you just have to find a bound on that.
If it is specifically just want the bound, then the value of mu should be given.
Sorry?
Actually, if the question says that you have to find the bounds, then it will be giving the value of mu, both the upper and the lower bound.
Yeah, I mean, it could have also been find.
In that case, we have to
in in this case, it is lower bound. Why? Because using weak law of large number, this is what it says: probability mod of x bar minus mu greater than delta is greater than equal to 1 minus variance of x bar by delta square. So it gives a lower bound on the probability. So,
ma'am, in the formula sheet, it says probability of x bar minus mu is greater than delta.
So the other, so the other form is also like one more. You can write here. So it can also be probability that mod of x bar minus mu greater than delta is less than equal to variance of x bar by delta square.
Ma'am, this is for upper bound.
This is upper bound.
Okay.
Ma'am, can you tell about at least and at most kind of thing in these both versions, ma'am?
At least and at most. See, in this case, first look at this case. Okay, so this is just probability. So let's denote this as small p. All right. We are saying this small p is less than equal to this, and this is going to be some number. Okay. So let's say to be k. P is less than equal to k. So P is less than equal to k. So maximum the value P can take is k. So we are saying the probability is at most variance of x bar by delta square. This is called at most. Maximum at most it can go till variance of x bar by delta square. Okay, maximum is that. But in this case, what happens is we are saying P is less than equal to k, right? So P is going to be greater than this. So the minimum value that the probability can take is 1 minus variance of x bar by delta square. That is the least P is going to take. So that is at least.
So this is really all limit.
Write it over there itself, ma'am, please.
This is at least. And this is at most. Okay. Probability is at most this much.
Ma'am, in the question it is asked, can you just go up to the question, ma'am?
Yeah.
In the question, we have the keyword lower bound, so that means we have to find the at least.
Lower bound on probability of A. Is it okay?
Okay, so we'll have to find the, okay, at least. Then.
Yeah.
Shall we move ahead?
Yes.
I think at least is minimum, at most is maximum.
So, ma'am, if inside like the sign before delta, like here if the sign before delta is opposite, okay, if it is less than equal to, according to the question, if it is less than equal to, then we'll be always getting this side as at most, like the upper bound.
Yeah.
Even if it's not asked in the question, we'll have to give the answer for the upper bound only.
Yes.
And if it's opposite, then we'll be giving the lower bound.
Yes.
Okay. So basically, the signs are always opposite, like
opposite,
inside. Yeah. And according to the question, we can find out that what bound we have to find if it is not mentioned.
Yeah. Okay, let's move to the next problem. So question number 10. Okay, so the first part is the question is x is uniform in 0 to 30 and we have defined y to be 3x. Okay, so the first question is y equal gx monotonic in support of x?
Yes.
Yes.
It's monotonic, right? So y is 3x. So y is 3x. It will be something like this. So you see that in the support of x, this is monotonic. So it is yes. Now the second question is, what is the support of y?
0 to 90.
0 to 90. Okay. Yeah, 0 to 90 is correct, but 0 will have to remove from here.
Why, man?
I mean, equal to.
Definition of support is greater than 0.
Yeah. Okay. Let's remove this part here. Let's to avoid the confusion. Even if it's there, it's not a problem. But
why are we removing 0? The variable can take the value 0. It's
it can take the value.
Density should be greater than 0, right?
Yeah, but it will be 0. I mean, so since x is between 0 to 30 and y is your 3x, so
y will go from 0 to 90, including
y
both.
will go from 0 to 90, right?
Yes, ma'am.
Yes, ma'am. Endpoints included.
Okay, it's okay. Let's keep it. Just to avoid confusion, or I will remove it.
Anyway, I think it is continuous, so
it doesn't matter. Yeah.
No, but sport matters. No, sport will change. Maybe probability does not matter, but sport definitely matter because density at that point is positive, right? Maybe the probability is 0, but density is positive, right?
Yeah.
Hello, ma'am.
Oh, yes.
And support what is related to density?
The continuous.
Density,
yeah.
Okay.
The support of y is like the set of all the y for which your y is that fy of y is greater than 0.
Okay. Fy of.
Yeah. How do you define the support? So support of any random variable x is set of all x for which fx of x is greater than 0. Okay.
But here, ma'am, y is not equal to fx of x. Y is not a density function here. Y is just a function.
But ma'am, as x is including 0, so y will also include 0.
Yeah, x is including 0, y will also include 0.
Yeah.
But as per the definition, we should not include the 0.
Because at 0, it will be 0. Yeah. That's why I told to avoid the confusion. It's okay to remove it. It doesn't matter much, but it's okay. But now it is clear that support of y is 0 to 90. This is clear, right? Support of y is b.
Yes,
yes.
We have multiplied 3 in the
Yeah,
x
you just have to
distribution,
multiply
no?
it. Yeah.
Okay.
Now find the distribution of y. So y is just 3x. And since
0
you
to
know
90.
that y is monotonic in this support, we can use the monotonic differentiable function, right? And what does it say? It says fy of y is fx of j inverse of y divided by mod of g dash of j inverse of y, right? So y equal 3x, and you can write x equal y by 3 here. And g of x is 3x. So we'll have to do g dash, and g dash is 3. Okay. So what is g inverse of y?
Y by 3.
Y by 3.
G inverse of this is g inverse of y. Okay. So this is same as fx of y by 3 and g dash of g inverse of y. So g dash of y by 3. Okay. And what is g dash of x? It is just 3. So even this is going to be just 3. So fx of y by 3 divided by 3. And what is fx of y by 3?
1 by 30.
1 by 30.
1 by 30. It's constant.
1 by b minus a, which is
So
30.
it is 1 by 90. So we got
90. Yes.
0 to 90.
Yeah, we got fy to be 1 by 90 for y lying between 0 to 90. Okay.
0 to 90.
So basically y is
With equal signs, huh?
Yeah, equal sign. So y is also uniform in 0 to 90. Okay. So B is correct. Now we have one more part here. So calculate probability y less than equal to 60. So what we got y to be uniformly distributed in 0 to 90. And we have to find the probability that y is less than equal to 60. So, yeah.
2 by 3.
It will be 60 by
2 by
90.
3.
Okay, so it is just what? Fy of 60, and it is 6x minus a divided by 90. So this is just 2 by 3. This is the answer.
Yes, ma'am. Good.
Ma'am, is this a formula?
Yeah, like if
X minus a.
x is uniform in a comma b, then the CDF is given as x minus a upon b minus a, or x lying between a to b. The same thing we have used here.
Can we get the same result using integration?
Yes, we can get the same
Then
result.
how to do it?
Okay, let's see it. So you have probability y less than equal to 60. This will be 1 upon 90 dx, and this is 0 to 60. It is 60 by 90.
Ma'am, dy it should be.
Oh, sorry, dy. Yeah. That's right. So you get the same answer.
Yes, ma'am. Move ahead.
Okay.
Hello, ma'am.
Yes.
Ma'am, there is a similar question in mock 1.
Okay.
Question number 3. Can you please just do it once?
Question number 3. What question is that?
Okay, 1 second. That is x is uniformly distributed.
This question.
Minus 1 to 1.
Yeah, I am just going to this problem here. Okay, so for this problem, what does it say? It says x is uniformly distributed over minus 1 to 1 and y equal 4 minus x square. So See, you have minus 1 to 1. X is uniformly distributed over this interval. And let y equal 4 minus x square.
Ma'am, this which you have drawn, it is CDF.
No, it's not the CDF. I mean, it's a distribution function, the PDF.
Okay.
So the height will be 1 upon 2. Okay. Now y equal 4 minus x square. Is it a monotonic function?
No, ma'am.
It is not a monotonic function on the support of x. So we cannot go through the monotonic differentiable function formula. So we'll have to go through, because in the monotonic differentiable function theorem, that is valid only if your function y, this function gx equal y, is monotonic in the support. That's how that formula comes. But if it is not monotonic, we cannot use that here.
So here why it is not
It has to be either strictly increasing or strictly decreasing.
Yes.
Here it is parabolic.
Here it is parabolic.
Oh, okay, for the function y. Okay.
Yeah. So it will come something like
it will vary between 3 to 4.
Ma'am, how do you get 1 by 2?
It is 1 over p minus
1 upon 1 minus 1.
Okay. 1 by b minus a. Okay.
It will look something like this. So you see that it is not monotonic, right? So what is the range of y? Oh, sorry, support of y?
1 by 2, how do we get? Like
1 by 2, this is how we get. So x is uniform in minus 1 to 1. So fx of x is
okay.
1 upon b minus 1. Okay. Now what is the support of y?
3 to
4. 3 to 4.
3 to 4. Okay. All right. So since we cannot go through the monotonic differentiable function theorem, we'll have to go through the CDF approach. All right. So how do we find the CDF here? So you see that support of y is 3 to 4. So any y that is less than
4
3
comes in support of y.
How does
3 to 4?
Okay, it is 0 to 4. No?
No,
No,
wait,
it is 3 to 4.
Not be 0 to 4.
Yeah, can you tell me what you're saying?
I'm saying why it is 3 to 4.
Why it is 3 to 4? Okay. So x is between minus 1 to 1. So you put x equal minus 1.
Yes, then we will get 3.
Then you will get 3.
3,
For x
yes,
equal minus 1, you get y equal 3. You put x equal 1, you get y equal 3.
3, yes.
You put x equal 0, what do you get?
Okay.
You get y equal 4, right?
Okay, ma'am.
So the support of y is from 3 to 4. Now you take any y less than 3. For any y less than 3, your fy of y is going to be just 0. Okay?
Yes.
This is okay. Now any y that lies between 3 to 4, okay? Your fy of y is what? This is probability capital Y less than equal to y. And this is probability, since y is equal to 4 minus x square. So y equals 4 minus x square less than equal to y. And this is same as probability that minus of x square is less than equal to y minus 4. And okay, so this is basically x square greater than equal to 4 minus 5. All right, and this is same as probability that x is less than greater than equal to 4 minus 5 and x is less than equal to minus of under root of 4 minus 5, right?
How did the minus part? Oh, actually it is root. Okay, okay.
Yeah, it is root. No? Yeah. So from here, this is now you can do the integration.
Yes, ma'am.
So
1 minus 4 minus y by 2.
So 4 minus y and x greater than this. So it goes to, no, not 4.
1.
Minus 1.
1.
It goes till 1.
1. Yes.
Yeah.
Half.
So this is 4 minus x square dx. Or I think it's better if we can do it through CDF only. Wait.
1 minus 4 minus 5. 1 minus square root of 4 minus y by 2.
Sorry?
1 minus square root of 4 minus y by 2 plus.
No, we can do
X greater than square root of 4 minus y is 1 minus square root of 4 minus y by 2. By 2 into 1 by 2, that is 2.
Okay.
Plus the second one is
x minus of 4
4
minus y
plus 1
minus of
minus
1 which is plus 1 divided by 2.
It's actually the same term, so 2 cancels.
So 1 minus it's the same term, so it just becomes 1 minus under root of 4 minus 5.
Yes, and then you differentiate it.
Then you differentiate it to get the PDF.
We got here.
But this is for y less than y lying within 3 to 4. Now what happens when y is greater than equal to 4?
From where we get this, ma'am?
Yeah, I didn't get this.
I didn't get this. How this step appeared? 1 minus.
So see. I will write it here. So x was uniform, right? X was uniform in minus 1 to 1. So we know that fx of x in case of this uniform a to b, it is x minus a upon b minus a. Okay. So if it is probability x less than equal to minus of 4 minus 5, this is basically fx of minus of 4 minus 5. Okay. So this can be written as minus of 4 minus y minus of a, which is minus 1. So plus 1 divided by b minus a, which is 2. Okay.
Okay. And for that one, it's 1 minus.
It's 1 minus.
This takes care of both the cases, no?
Ma'am,
yeah.
Actually, this
Yeah,
one
I
is for
better write both the cases.
minus case, and the earlier, the first one was for
the first one.
1 minus under root 4 minus y.
Okay. So this you saw. Now probability. I will not write. Just leave this part. Okay, let's do it here. So probability x greater than equal to under root of 4 minus 5. This can be written as 1 minus probability x less than equal to under root of 4 minus 5. Okay. This is just 1 minus fx of under root of 4 minus y, and this becomes 1 minus under root of 4 minus y minus of this minus 1 divided by 2. So if you do this 2 minus 1, you get the same thing, right? So we already got the CDF. To get the PDF, we just have to differentiate. Okay. So fy of y
1 by 2, 1 by square root of.
So you have this as CDF. So if you differentiate this, you get 1 upon 2 root y. This is minus and minus y again. So
y goes away, minus, yes, it's become plus.
Yeah, plus 1. So this is for y when lying between 3 to 4. And 0 otherwise. So this is the answer.
Such a question is going to be asked, ma'am. This was the toughest question in the.
Yeah. So, ma'am, basically, if this question is asked first, we need to check the monotonicity, right?
Yeah. First, always check the monotonicity. If monotonic in the support of x. So if it is monotonic, you can directly use the formula. But if it is not monotonic, use the concept of the CDF.
Okay, like that is where I went wrong.
Yeah.
The concept of CDF becomes quite tough. Although it
Ma'am, from CDF to PDF, we will differentiate or integrate.
So what is the relation?
Differentiation of CDF is PDF and integration of PDF is CDF.
Exactly.
So to get the PDF, you need to differentiate the CDF, right?
Yes.
Okay. This is the last problem we have.
Can it be possible?
There is another one like below this, I guess, with CLD.
Yeah, that is also there. I mean,
that
yeah,
like that's quite difficult.
Okay.
No, we will get this PDF tomorrow morning.
We'll get tomorrow morning. Yeah.
Okay.
All right.
Yes, ma'am. It will be better if you arrange one extra session for other problems.
Extra session. Today is already Friday. Tomorrow is just Saturday, and then you have exam.
So, ma'am, what will be the weightage? Like a brief idea among 5 weeks.
The weightage.
And there are some questions left.
Quiz 1.
Uh-huh.
The same way you had seen in quiz 1, the weightage will be kind of same.
Okay.
Yeah.
And we'll expect the problems like mocks.
The concepts will be same, but the problems definitely will vary. I mean, a lot. But the concept you will
No,
use.
actually, distribution of marks among different topics. Some marks are allotted for CLT and weak large numbers. That's why I really.
Distribution may also vary here.
Will there be distribution from week 1 to 4?
Week 1 to 4, it will be very less if it comes. I mean, you should know the concepts done in week 1 to 4, but mostly the questions are going to come from week 5 to 8. Most of it.
Yeah.
So you just focus more on week 5 to 8. Even the questions from week 1 to 4 it comes, you should be able to answer.
Like among 5 to 8, where to focus because time is so less.
Ma'am, can we expect around 50% weightage from week 7, 8?
Yeah, yeah, you can expect that.
Okay.
At 40 to 50, you can say. Yeah.
Okay, so 40 to 50
From 7 to 8.
7 to 8.
I don't even remember.
Okay.
But the topics will be same kind of. Like if you look at week 7, you should know samples, you should know weak law of large numbers, you should know moment generating. There are very limited topics. So every topics you should just know the idea, and if the question comes off from these topics, how do you find it? All that you should be able to pick up. So
And the difficulty level, ma'am?
Will be like in mock, or it will be more difficult, ma'am? Like the difficulty level.
No, it will be difficulty level will be kind of same. It won't be so much difficult.
Okay, ma'am. Thank you.
Just be confident with what you have studied. The topics that is there in each week, like if there is week 4, you have all these distributions and continuous random variable, how to define CDF, PDF, all those things you should know properly. All the distributions you should know properly. So,
okay.
Yeah, I mean the topics are less. It just you should know.
The gamma distribution.
Yeah, yes, ma'am.
Gamma distribution. Gamma distribution. You have studied in week 8.
Yes, ma'am.
The last topic. So
Yes, assignments we have.
So
8.3.
Even if it comes the gamma distribution and all, so the formula is already given to you. I mean the PDF, the CDF, expectation, variance. So
actually, we have not gone through the activity questions of those distributions.
Ma'am, can you provide the formula for CLT and W weak law of large number?
No, you'll have to.
Yeah, no, ma'am, it is there, ma'am, for the formula sheet.
It is there.
Madam, are we finishing this 12 number question?
Yeah, we'll finish that.
Please, please, please.
Okay, let's finish this first. Okay. Okay, the question is a fair coin is tossed n times. So you have a fair coin and you are tossing it n times. So let's say you have.
Ma'am, can I request somebody's got some buzzing noise? I think Manoj Kumar.
Yeah, if you can mute yourself.
Manoj Kumar, I think, has to mute, ma'am. Yeah, thanks. Thank you, ma'am.
Yeah. Okay. So we have a fair coin which is being tossed n times. So let's say we have, I can write x1 to xn. Okay. And each of these xi's will represent the tossing of a coin once, like one toss of a coin. One toss of a coin. So if you do x1 plus x2 plus up to xn, you will get to know how many times a head or a tail occur, whatever the random variable we're interested in. So you have to use the weak law of large number to find the minimum number of tosses of a fair coin needed, so that probability that the average number of heads obtained differs at most 0.02 from 0.5 is at least 0.95. Okay, so you can see a lot of numbers here. Let's break it down. So you have to find the probability that the average number of heads obtained. So basically each of these xi's will denote okay. So if you write x1 plus x2 plus up to xn, it should give you number of heads obtained. So basically each of these xi's represent whether the success is, how is a success defined? How is a success defined
One.
here? No, success is defined as getting ahead.
Okay, that way.
Getting ahead, right? So each of these xi will either be 0 or 1. So 1 will be when you get a head and 0 will be when you get a tail. So when you sum all these xi's, you should be able to get total number of heads that you obtained. Now if you do x bar, so x bar, which is x1 plus x2 plus up to xn, this will give you by n, this will give you average number of heads obtained, right? This is average number of heads obtained. So this x bar differs at most 0.02 from 0.5, right? So first let's write weak law of large number. So we have probability mod of x bar minus mu greater than delta is less than equal to variance of x bar by delta square. And the other form we have seen is probability that mod of x bar minus of mu less than delta is greater than equal to 1 minus variance of x bar by delta square. Okay. So what does the question says? You have to identify which weak law of large number you are going to use here. Average number of heads obtained differed at most 0.02. So from 0.5. So what is 0.5? 0.5 is basically probability of occurrence of head, right? So here this is half and this is half. And when you write mu is 0.5. So it varies at most 0.02. So 0.5 plus 0.02 and 0.5 minus 0.02. So your sample mean should lie in this interval. Okay. Is at least 0.9. So which formula should we use here?
Second one.
And the second one.
The second one. Okay.
Lower bound.
So what we are going to get? We are going to get probability that mod of x bar minus 0.5 less than 0.02 greater than equal to 1 minus variance of x bar is sigma square by n. And what is sigma square?
P 1 minus P.
0.25.
P 1 by 4. 1 by 4 into 0.02 square. And we are saying this is at least 0.95. So this is at least 0.95. Okay. Now just solve it. So you get minus 1 by 4 into 0. But there should be
n is missing.
Sigma square by n. Yeah. N. So 4n 0.02 whole square greater than equal to minus 0.05. Now if you change the sign, remove the minus sign, your inequality sign will change. So this becomes greater than equal to. Okay. So you have n greater than equal to 1 upon 4 into 0.02 whole square into 0.05. And this turns out to be I think 12500.
Yes, ma'am, it's correct.
It's correct. So n should be greater than equal to 12500. This is the lower limit for n that you should expect. The correct answer is 12500.
How did we get that variance?
How did we get the variance? So variance of x bar is sigma square by n. Okay. And sigma square is just variance of x by n. Okay. And variance of x is p into q. Right. Okay. So p is 1 by 2, q is 1 by 2 divided by n. Okay. It is 1 by 4n.
Sure. Thank you.
Okay. Yeah. So is this clear? Okay. one more question, then we'll close it. Okay. So there we had.
Here n is to be calculated.
Yeah, n we calculated. No, n is greater than or equal to 1 to 500. We had to find. We had to find the minimum number of tosses. So the minimum number of tosses required is 1 to 500.
Yes, ma'am.
Yes,
Ma'am, that this question follows Bernoulli.
What?
Does it follows Bernoulli distribution on this question?
Yeah, I mean, you're dealing with tossing of a coin, so you know it is
1 and
Bernoulli.
0. Oh, thank you.
Okay, so it's the same problem, but in this case we have to use CLT. So how do we use CLT? The problem was, what is the probability that mod of x bar minus 0.5 less than 0.02 is greater than or equal to 0.95. This is a problem statement, correct? Now you have to use CLT here. So for CLT, we want to bring it down to this S minus n mu upon sigma root n. This should be normal 0, 1. And in this case, this n is what n we have to find, and mu is 1 by 2. So we can write it 0.5n divided by sigma. So sigma is under root of 0.25 and root n is root n.
Sigma is 1 by 4.
Here you have to divide by root n.
Sigma is
divide by root n.
Sorry? No, it's sigma under root n.
Yes, but to get this form, you have to divide by root n. Divide by n.
You mean in the problem? Yeah, we'll do that. So we have to divide by
n.
So let's write it. So this is x1. X bar is what? X bar is x1 plus x2 plus up to xn by n minus 0.5 less than 0.02 greater than or equal to 0.95. Okay. And this is what? Basically this is x1 plus x2 plus up to xn minus 0.5n. So you see, this is your S and this is your mean divided by n. So 1n we can root n we can put it on the right hand side. So we can write root n here, and here it will be 0.02 root n. Okay.
How, ma'am?
You just multiply and divide by root n.
Okay.
So this is n here. You can write it as root n times root n. Huh? You can write this as root n times root n. So one root n you leave it here, add the root n, you take it to the right hand side. That is what I have done here. Root n and other one I have taken it to the right hand side.
Ma'am, what is the value of sigma?
That will come.
Okay.
So 0.95. So we got this S minus this n mu and sigma root n. Sigma, so what is sigma here?
Sigma will be 0.25.
Root 0.25.
0.25.
0.25, right? Okay. So 0.25 we multiply and divide here. So 0.25 under root, it comes out to be 0.5, right? This comes
Sigma
out
is
to be
0.5.
Yeah,
Sigma is 0.5.
0.5n divided by 0.5 root n. So divided by 0.5 here and divided by 0.5 here. So you got this to be mod of z less than equal to, so 0.02 by 0.5. It comes out to be 0.04. So 0.04 root n greater than equal to 0.95. Okay. Till here, is it clear?
No.
Yes, ma'am. Yes, ma'am.
How did you get this?
So this is S. This is S, right? x1 plus x2 plus xn.
Yeah.
And 0.5 n is n mu. And 0.5 root n is sigma root n.
Yeah.
So this is normal 0,1 form. So that we can write it as z.
Yeah, no, that thing I understood. Like this 0.04, where did it come from?
This is 0.02 divided by 0.5.
Okay.
Right? After this, so you see mod of z less than 0.04 n root n. So this is nothing but probability that your z lie between 0.04 root n to 0.04 root n. Right? And this can be written as fz of 0.04 root n minus fz of minus 0.04 root n. Right? Now just look at the graph here. So okay, this is some positive value. So let's say this is your A. So fz of A is this, and this is some negative value. So this is minus A, and this is this minus this. So fz of A is going to be same as 1 minus fz of minus A.
So 1 minus 2 fz of.
Right? So this can be written as 1 minus fz of minus 0.04 root n minus of this. So it becomes 2 times.
Ma'am, I have a doubt here. The whole area under the curve is 1. So when you take out the fz of the minus A portion, what happens to the portion to the right of A?
Wait, what did you say?
The whole area under the curve is 1, correct?
Okay.
So when you take out the portion which is from left of minus A, and you're saying that the probability of fz of A is just 1 minus the portion of fz of minus A.
Okay, see.
And what happens to the portion to the right of A?
Yeah, wait.
We are calculating about 0.95 probability, sir.
We are saying so fz of A, okay, fz of A is this part. Then you have fz of minus A. So you have this minus A and you are subtracting this. So basically you are getting this inside part, and you are saying this should be greater than equal to 0.95. So this should be greater than equal to 0.95. Okay. This area is 0.95. So the remaining, if let's say this is 0.95, the remaining, the tail area is going to be 0.05. Clear?
Okay.
Now, now you see that fz of A is just going to be 1 minus fz of minus A.
right? FC
Yes,
of
ma'am.
A just going to be 1 minus FC of minus A.
And ma'am, we can say FC of minus A is equal to 1 minus FC of A.
So FC of minus A is also same as 1 minus FC of A. Yes. So yeah, let's go with this. So we can write FC of 0.04 root n minus FC of minus A. So 1 plus FC of 0.04 root n. Okay. And this is greater than equal to 0.95. And this becomes 2 times FC of 0.04 root n minus 1 greater than equal to 0.95. So this minus 1 will go on the other side, and it will become FC of 0.04 root n greater than equal to 1.95 by 2. So this is 0.975. Okay. And for what value you have 0.975 as the probability. So this is
1.96.
FC of 1.96. So just compare both the sides, and you get 0.04 root n to be 1.96. And from there you get n to be 1.96 by 0.04 whole square.
It's 2401, ma'am.
So this is, you're saying 2401. Okay. So from there you got n should be greater than equal to 2401 to get this desired.
So, madam, this CDF of normal distribution will be given to us. Na? Any value which is required.
Yes,
to
any
be
value that is required will be given.
So we have to reduce our expression to the form in which that particular value which is given to us is there. Suppose fg of minus 0.04 root n is given, then we have to reduce it to that form. Otherwise, we have to reduce it to 0.04 root n, whichever value it is given.
Yeah, whatever value is needed in the problem to solve it, it will be provided to you. So,
but it could be given as both. Na? It could either be given as cumulative fg of 0.04 root n, or it could be even given minus.
See, 0.04 root n will not be, something like this will not be given to you in the problem. So in the problem,
it could be a positive value, fg of positive value or fg of negative value.
Yeah, both negative or positive is possible, but you cannot expect in the values to be n given.
Yes, of course. Yeah. That n we have to calculate that.
Yeah.
Of course.
This 1.9 fc of 1.96 value is not in the mock.
It's not in the mock.
Yes, ma'am. That's
yes,
why
it is not given.
Okay.
Ma'am, can you analyze the both of these questions? Because
okay, so why both the question had been given to you? So for the same problem, I mean, you wanted to find a bound on this probability over here. You wanted to find a bound on this probability, and you see that to get this bound on the probability that your sample mean mod of x bar minus 0.5 less than 0.02 greater than 0.95. So this is, you are getting this bound for a very larger n. It means you have to toss a coin at least 12500 times to get this. But to get the same result, the CLT, you need a much lesser value of n. So you see that even for a n which is just greater than 2401, you can get this bound. So CLT is a much stronger property here, you can say. Much stronger result it gives.
Excuse me, ma'am. Any more questions left, ma'am, or is it done?
No, it is done.
Thank you, ma'am. Good night, ma'am.
Yeah.
Ma'am,
Yeah,
please
thank
give
you.
the answer sheet for the quiz one also, ma'am. Solution. booklet.
Answer sheet for
Yeah. Mock one also.
mock one is all okay.
Only
Mock one,
solutions.
they're not okay. Solution thing we can give, yes. Tomorrow we'll provide.
PDF what you have given right now to us. Just
Yeah.
followed ones will be helpful for us. Thank you.
Yeah, okay.
Ma'am, this will be uploaded by tomorrow, ma'am. Whatever you discussed today.
This will be uploaded by tomorrow. Yeah.
Thank you.
Ma'am,
Yeah.
we can find the recording of this session in the calendar, right?
In the calendar, yeah, but tomorrow.
Okay. Thank you, ma'am. Thank you so
Ma'am,
much.
please
Thank you,
update
ma'am.
mock one also.
Mock one.
Hello.
Yeah, that also will get updated. Like not many problems were there.
Okay. Thank you, ma'am.
Not so easy. Okay.
Yes, so many
Please
problems
also
were similar,
upload the
but
solution.
2-3 problems.
Sorry.
Can you also upload solution to week 5 and 6, please? Mock
Yes.
5 and 6.
Tomorrow it should get uploaded.
Thank you.
Yeah. So I've also pasted one link in the chat box just now. So in case it gets a little delay, so you can also see the previous term solutions. So, but it should get updated by tomorrow morning. You can refer to this too.
Okay, thank you, ma'am.
Okay, ma'am. Thank you, ma'am.
Yeah, thank you all. Yeah, bye. Good night. All the best.
Thank you,
Thank
ma'am.
you,
Good night.
ma'am. Thank you so much.
Thank you.
Thank you, ma'am.
Thank you all. Thank you.
Thank
Good
you so
night.
much, ma'am.
Yeah.